Welcome to the DataBench final event. Thank you very much for joining us this morning. We will have a wonderful program today with you. I will not steal a lot of your time because you will see that our agenda is quite packed. But let me provide some initial information so that you can understand the way we will run the session today. First of all, this is a session titled Evaluation Schemes for Big Data and AI Performance of High Business Impact. I hope you are all interested in this topic. 3 years ago, more or less, when we started a project, we discussed and we thought how difficult it is to understand what is the impact that data technologies have on business processes of companies. And then we understood the difficulty of relating technical indicators with business indicators. And we said, okay, we have to do something. People should have some tools at their disposal so that they can measure that somehow, and they can understand basically how some of the technical choices have an impact on the business side, and be able somehow to quantify that and be able to compare themselves with other companies that are working basically in the same sector and in the same ecosystem. And we started a group of companies to start on that. And today what we are doing is basically sharing with the audience everything that has been generated by the DataBench project. You will see that there are a lot of things that you can do with the tools that we have prepared. And I hope that this session will really be comprehensive and very useful to all of you to understand a bit better how you can use the tools that we have generated to make those measurements that I have mentioned. Before starting the session, let me share with you also some rules that we will apply to this session. First of all, I would really like to ask all people, but also our speakers, not to use the mic and not to use the video while they are not making the presentations. Then you all have the opportunity to participate. In fact, that's what we would like. We don't want to have a lot of people talking to you in an unilateral way. We really want you to participate, to give your opinion, good or bad. And for this, you know that you can use the WOBA platform. I'm not sure if you are connected just through Zoom or through WOBA platform. If you go to WOBA, you don't need to use the video, but still you can put your messages in the chat. So basically, if you want to make comments, use the chat function. If you want to make questions, then use the Q&A function. You will see that one is besides the other. If you have any question, just put it on the chat and I will follow all the messages so that I can help you during the session. Then, if you have any technical issue, we have here 2 email addresses. Please drop an email to them and we will really help you in parallel to the session so that no one miss any of the contents that we have prepared for you. I would also like to thank our sponsors. You know that EBDBF this year counts on a great amount of sponsors. The DataBench project is one of them. So we are really thankful because without them, this event would not be possible. So thank you very much for that. And without further delay, let me tell you a bit about who will be in the session today and the way we have prepared the program. In the very beginning, when we were working on the workshop, we thought, wow, this will be long, so maybe people will not stay so much time. But then we started to call some speakers to work on the content, and finally, we realized that we will have really very limited time to do everything we want to do today. And you will see it also because we have a good amount of speakers coming from the DataBench project, but especially we have a lot of speakers that come from outside and speakers that come from all over the world. In fact, we will have people from Europe, of course, but we will also have people from China, from America. So let's cross fingers, and I hope that everything will work well from a technical point of view. The chairs of this session are Mr. Richard Stevens, he is Consulting Director at IDC Italy, Coordinator of the DataBench project, and then myself, my name is Nuria De Lama, I'm European Programs Manager at Atos Research and Innovation, also member of the Board of Directors of the Big Data Value Association, which is organizing this event. As mentioned, there will be a lot of keynotes and panelists. Here in these slides, you can see all of them. I think it's very difficult to go through the CVs of all of them, but basically what I would like is to point you out to the website where we have included the CVs of all of them. And what it is more important is to tell you about the dynamics of the sessions today. Basically, we have prepared 2 parts so that it is easy to understand the content. The first part is titled Big Data Benchmarking Landscape and Big Data Blueprints. And as you can imagine, basically it will be composed of 2 parts. The first one will be devoted to understand AI and big data benchmarks. So we will count on an excellent panel of speakers coming from all over the world, as I mentioned before, that will tell us about some of the benchmarks that exist in the market nowadays. And my colleague Arne and Todor from the DataBench project will moderate this session, providing some hints on why these benchmarks are important and the way they can be used. You will also be able to give your opinion about the fact that we may include other benchmarks or anything you want to say in the chat. Then the second part will be devoted to understand big data blueprints. And for this, we've been working along these 3 years with several projects of the Big Data Value Partnership. And you will see basically the work we've been doing with the projects. Many of them will give their opinion and will participate today in the session. That will happen before the break. Then we will have a short break so that all of you can have like a coffee. I would say, I was going to say a quick lunch because of the time in Brussels, but no, I think that you will have basically time for a coffee. And then we will devote the second part of the workshop basically to the business and the demo part. And the first part that we will have is the business framework. You will really understand what I mentioned at the very beginning. So how to relate all these technical benchmarks with the impact that measuring those or taking some technical choices have on the business processes. And for this, we will present basically the business framework that has been prepared by the DataBench project, but we will also count on a couple of companies. One of them Whirlpool, the other one is called Field, and they will also answer some of the questions we have prepared for them based on the work we've been doing along these years to understand what are the most important business indicators that need to be taken into consideration in this framework. So I think it will be really useful because so far in the program, I didn't see anything that puts in connection both technical and business indicators, and here you will learn quite a lot. And we will finalize the workshop basically with a final session devoted to demos. I think that talking about the frameworks in a conceptual way is important, it's interesting, you need it in order to understand how the tool has been created. But finally, what you want as a company, as a project, as an institution, is having some tool sets that help you do the things. So basically, this is what we have also programmed, and my colleague Tomás Pariente will lead the final session, where you will see in real time what are several journeys, like if we were having different users, and you will see how the tool can be used if you are coming from a research organization, if you are an industry, and depending also on what you want to do with the toolbox. You will see that there are many functionalities, and all this will be explained before. And to finalize in this same session, we will have also the presentation of the Observatory of Artificial Intelligence, which is an add-on that has been developed in the benchmark, the DataBench project, and will also be shared with you in case this can be useful also for all the companies that are attending the session today. So as you've seen, we have a lot of contents prepared for you. And again, as I mentioned, even explaining the agenda is quite long. So I will stop here and I will let my colleagues moderate the different sessions. As mentioned, I will pay attention to the WOBA platform, to the chat and to the questions. Please don't hesitate to participate during the session. Tell us if you have any problem, if you have any concern. And with this, I would like to give the word to Richard Stevens, the coordinator of the DataBench project, who will provide a general overview of the project so that you can also understand how all the different pieces come together to provide value to all of you. And then we will jump directly to Arne, my colleague, who will be moderating the first session of these 4 structures that we have created for the DataBench agenda today. So thank you very much for your attendance. And again, Richard, the floor is yours. I think you can share the screen.
Okay, thank you very much, Nuria. Welcome, everyone. And thank you for taking the time to come and listen to what we're doing. I'm going to share my screen and do a short presentation introducing you to DataBench. And I think...
You have to share your screen, Richard.
Can
then
you
for
see
the
that?
others, as I mentioned, try to avoid the video if you are not talking. That would be good.
Perfect. All right. So this presentation is virtual. You'll see that it's actually my session is being held in the garage. So that's the address. That should be apparent. The reason for that in this next slide. I guess maybe some of you know some of these garages, and these garages basically show the importance of getting the value out of data. Actually, does anyone recognize these garages? This is the original Google garage over here. Here we have the Apple garage, the Amazon garage, and actually the Facebook living room. But I couldn't find a Facebook garage. In any case, these people had found that they had significant data and found that they could leverage the value of that data. That's what's happening in industry today is that people are realizing that they have a significant amount of data and that they want to perform analytics on it and derive the appropriate value that they can from that. So what happens is they realize that these companies are doing it, and they are in the same situation. So they have data, but they don't really know what to do with it. And all of the suppliers are coming out and saying already, we have exactly what you want. We know what's best for you because it's what we sell and it's what we have, and here it is for you. This is what you need to do big data analytics. But it would be nice if it was just 6 doors that people could go to. Their organizations look at their data and they think, oh, well, this is what it actually looks like. And data there's companies and providers providing an incredible array of tools and analytical software to go through their data. And so they find themselves in a conundrum of figuring out which tools and which processes to measure. That's where DataBench comes in. Our idea was that we could match business metrics to technical benchmarks metrics and derive the best tools for people that to analyze their processes. So essentially what we found is that we had different data pipes coming from different processes, and they were performing different processes in different companies, which we were able to measure and give metrics. On the other hand, they found that they had different objectives in companies, and that their end objectives were to do things like increase revenue or increase customer loyalty or reduce time to market. And so the question is, if my objective is to reduce time to market or to improve my calculation speed, for example, in the financial sector, what kind of benchmarking should I be doing to measure these processes? So what we did in DataBench was, first we were looking at the different types of analytical processes and benchmarking that was going on. What were people actually doing? We imported as a starting point, the BDVA reference model for different types of analytics. And we saw what people were actually interested in benchmarking. This was our starting point. At that point, what we needed was to figure out what companies were actually interested in doing. So we carried out a survey across 700 organizations to ask them what they were really interested in doing. And we found, of course, things like cost reduction, time efficiency, revenue growth, exactly what we were saying before. We also asked them what kind of analytics they were able to do, what kind of data they had, what kind of storage, what kind of data management they had, so that we could map these. We asked them what kind of paradigms they were using. Were they using batch processing or stream processing, or did they have different metrics that they were trying to prove, and what kind of actual techniques they were using. Oop, that went a little bit fast. So then what we did is we correlated the different processes and the different benchmarking tools to see if there was some correlation between the different tools and what they were best at doing. And then we looked at the different benchmarking tools that were available for doing these types of analytics. You probably all remember the Intel Anthlon comparison, which was more suitable, which was a better processor. That was the origin of the benchmarking community. Not obviously with the Intel 4, it started much earlier. But this was a big battle, and benchmarking was a big part of it. Intel, it was originally thought, had the higher clock speed and therefore was the better CPU. But when they were actually benchmarked, put one against each other, and looked at floating point operations of real application loads, then we found that there were other processors out there that actually were doing better. So that kind of benchmarking is in the hardware domain, but of course, there's with these companies, people are using the software benchmarks for things like database management or compilers or things like that, and that's where DataBench comes in. We're looking at actually these types of applications and seeing where analytics applications make the heaviest use of these types of benchmarks. And what we've done is we've, first of all, and you'll hear this now from Arne and some of the people in our community, is we looked at the different benchmarks and we looked at what they were made up of and how they were organized. And then later we looked at the business characteristics that were best proved using these benchmarks. And you'll hear that from Gabriela and Erika. And finally, what you'll see is we made a tool that could collect the different benchmarks and put them one up against another so that they could actually be compared. So different users could actually use DataBench, the DataBench toolbox, and figure out which kind of benchmarking application best fit their needs and best promoted their objectives for doing big data analytics. So the toolbox, first of all, has a general information area where you can find information about the benchmarking, the applications that are out there, about the different communities, about the different ways of doing benchmarking, and what have you. But then inside, it has different functionalities for technical people who actually want to search for the best benchmarks and run them, for business people that want to figure out what kind of benchmarking perspectives they can use, and finally for the benchmarking providers as well, and they can put them and run them, put their benchmarks in there, run them, and compare them to the other benchmarks. So this is basically what we've done in the DataBench project. Is we provided this toolbox and the information to use that and to assess benchmarking in your organizations. We are now involving the community, and other people are coming forward and using our benchmarks and taking it. And we're going to talk a little bit about that now. So what I'm going to do is I'm going to ask Arne to begin and take us through the different types of benchmarks that we're looking at and their significance. So
yeah. Maybe Richard, I think that you should stop sharing your screen so that we can share. Screen.
No, Arne just needs to take it.
Oh,
Okay,
it says you cannot share the screen, so let me do that.
You want to show, Arne, do you want to go directly to your slides? Because we have a slide with the speakers. So if you want, I can show it.
Yeah, I have that too. So that's fine. I'll go to my screen here. So you should be able to see this now.
Yeah.
Yes.
But we don't see it in presentation mode yet. Perfect.
So, okay. So
That's
now
good.
we are going into the current landscape of big data benchmarks. And for this, we will have 3 presentations of representative benchmarking communities and activities I'll give a little introduction. So my name is Arne Barre from Sintef and technical coordinator in the DataBench project. And it will be a conclusion by Todor Ivanov, who has been working much in the benchmarking community, also involved in DataBench. We have set up the session now with 15 minutes presentations of 3 representative benchmark communities. I'll come back to that. Richard already presented the BDVA reference model that we were part of development community around earlier. To the left, you see our high-level aggregation of aspects here into what we call a generic data pipeline. And this is what we'll be using as a suitable grouping of both benchmark and results from projects, as well as also categorization of tools and components available from the big data and AI landscape. So it's also suitable in the AI context. You will be familiar with the evolution of the new data, AI, and robotics community, and might have seen this model from the Strategic Research, Innovation, and Deployment Agenda for AI. So also this is quite applicable for an AI pipeline with the mappings as you see here. And in general, you will see that we are coming back to this during today, how we are grouping benchmarks and also project activities and results, as well as available tools and components to the initial phases of data acquisition and collection with data ingestion. That include getting data into the system, both historical data and streaming data, data storage and data preparation, data curation, further data analytics, including also machine learning with training data and validating and operational machine learning, and further the visualization and also external action interaction. We are also using this in the DataBench toolbox that we will get the presentation and demonstration of later after the last part of our sessions. So this can be found online at the DataBench website. And among else, it includes a catalog of all of the collected benchmarks that we have represented into the system. It's more than 50 that are categorized according to various dimensions. An example we will hear about now is from the Hobbit benchmark platform. You see also some of the tags that are used for the search for benchmarks. So we have descriptions of all of these benchmarks in various categories and with details and references, and also an overall perspective of a lot of different benchmarks, how they are categorized into these areas of data ingestion, data storage, data analytics, data visualization, and action. We have today selected 3 of these communities that we will present for you: the Hobbit benchmark community, the A-Bench and ML-Perf, and also the Bench Council community, which have representative benchmarks among all of these. But we found these in particular relevant. So when we look at our agenda now, we will go through and get the presentation of the benchmarking platforms and AI perspective from Axel Ngonga. He is also the lead of BDVA Task Force 6 on benchmark together with me. And then we will go to China to hear about a large effort of benchmark gathering or grouping and development under Bench Council by Fanling Gao. And then go to India and hear about ML-Perf, which is also a US effort. Because of the time difference, it's much better to talk on that from India today than from US. It's still early morning there. And they're probably busy with quite other things now. And then we will have a conclusion summary of this by Todor. So Axel, as I mentioned, is involved also in BDVA, where we have a special interest group on benchmarking, starting with big data, but now also moving into AI. So I will leave now Axel Ngonga the opportunity to introduce this from his perspective. And then I will stop my presentation now so that Axel can take over. So I will stop sharing my screen, and then Axel will be able to start up and do his presentation. Let's see how we do that.
Thank you very much for the introduction, Anna. Greetings to all. For those who don't know me, I'm Axel. I am a professor at Paderborn University, and I basically co-lead the special interest group on benchmarking at BDVA. And Anna, I think you're still sharing your screen, which means I cannot
Yeah,
share.
I'll do the stop sharing here. So now you should be able to share your screen.
Now it should work.
In cui vuol fare una call per
Fantastic. Can you all see my screen?
il piano operativo di business nei prossimi 12
Someone has the mic open. Can I ask people attending the webinar not to use the mic? Please mute yourself.
il pezzo dei servizi di self provision.
Yeah, so Italian in the background.
Maybe you can mute the people
La console di controllo verrà completata con funzionalità dispositive per agire su
can you mute the attendees so that we don't have the background noise?
I can't turn them off. I don't know who that is.
It is definitely not me. My Italian is not that good.
You can go ahead.
Sounds like Chiara.
All right.
Allora, nei clienti di bus, solo per clienti di bus. Ho messo per i clienti enterprise la possibilità.
I can't turn
It's
them
an
off.
option where you can mute
Questa cosa
everyone,
aggiunta
but
di
the
server
panelists.
non la possono fare tutto mascherato per i clienti se offriamo il database as a service.
So
Ma ho scritto
gonna wait.
per i clienti enterprise sarà possibile anche gestire tramite console infrastrutture.
But
Chiara, turn off your microphone.
Okay, now the mic is turned off. I will do my best to not go beyond the 10 minutes anyway. So I'm basically here to present some of the work that we did within the Hobbit platform. And basically, Hobbit was designed to be a holistic benchmarking platform. And although we had linked data and knowledge graphs in mind at the beginning of the project, i.e. that was our main focus, one of the things that we really focused on during the project was building the platform in such that it can be used for other applications. And you're going to see that it is being used for some tasks which are very AI relevant. So the requirement we gathered for the platform were actually gathered within different surveys, which we conducted with industry and academia. We had 97, basically 180 participants roughly, both from industry and from academia, which basically gave us requirements pertaining to what they would want from such a benchmarking platform. As I said, the focus was on knowledge graphs, but there a lot of the tasks that one has to carry out in knowledge graphs are number one, generic, and number two, basically are very heavy on machine learning and AI techniques, knowledge graphs being regarded as being an important part of a knowledge representation for AI. And the result was basically the Hobbit platform. Some of the requirements that we gathered were all around the way we represent data internally, the way we make the results available, and basically the access to the results, i.e. the benchmarks themselves, the data generators, and of course, the results of all the experiments. So one of our main focuses was to make sure that we build a fair benchmarking platform, i.e. that results are findable, accessible, interoperable, and reusable, that we have fair conditions when we run the experiments, i.e. that we have a separation between the systems or the part of the hardware where the benchmarks run, and basically where the data is generated as well as the systems run. So those were all separated. And I'm having a bit of trouble with my background here, but don't worry about that. Let's focus on the content. Scalability was important. A lot of the benchmarks which were available were such that they could be run locally, but being in reality and in companies, a lot of the data is distributed and the algorithms have to run in a distributed fashion to simply cope with the scale of the data, which is of importance at industrial scale. Some of our surveys basically revealed that companies used data in the order of petabytes, and we wanted to be able to scale up to such large data sets. The platform is open, is available. You'll have links at the end of the presentation. You can download it, use it at your own premises, and so on and so forth. Important was also safety and security. So basically, you have different encryption layers, role management, which allow basically to ensure that the flow of data is such that it can be fully configured. And portability was also super important. So yes, you can run the platform locally, but for a lot of companies, it was important that they can run algorithms and tests in the kind of centers or environments in which that would actually run the platform, i.e., for example, having data running on on Amazon, either Amazon Cloud or the Google Cloud or the like. And we basically made sure that the platform is modular in such a way that modules can be exchanged and the platform can be ported to such systems. A port to AWS is available on the platform GitHub. Internally, I'm not going to spend much time on this, but what you need to know is that the platform, when it's not running a benchmark, basically makes data available, and that's basically the experimental data of all the experiments which have been run on the platform already. There's an analysis module, storage module. You can basically query the platform using a web interface, or even if you want, download the corresponding knowledge graph. And when you basically engage a benchmark, we have different task generators, which are based on real data. I'll show a couple of examples in a second, as well as data generators. And those basically can be used to generate data and tasks at scale. And basically, once the benchmarking system or the system to benchmark is connected, one can then run the benchmarks with these pre-configured tasks and data generators. We support bulk loading as well as obviously streaming, so that such benchmarks can be easily executed with the platform. After the run, there is an evaluation module which contains some artificial intelligence, which basically allows to gather the corresponding results, filter them, and make the results available to external people. External basically being people who have the right to access corresponding results. So if you deploy the platform locally, of course, you'll be on your premises, but you also have a cluster where the platform runs, where you can basically run open experiments. Okay, the platform has supported 14 challenges, has more than 1,000 users now, and has been used to benchmark more than 200 systems. And if you go to the platform now, to the master, you'll find that you have access to more than 15,000 experiments, which were run across 8 different categories of benchmarks. The 8 categories are totally aligned with the 4 steps, which Arne showed in his slides. And I'm just going to give you a very, very brief overview of the types of benchmarks and data sets which are available in a platform right now. So before I get to that, I promised you to talk about data generators. So one thing that was important was to make sure that the data that is used for the benchmark actually reflects what you find in industry. So we have 5 data generators available, and there are actually even more which can be connected to the platform. But directly in the platform, we have 5 data generators which are based on real data. And the data is basically transportation data from Belgium, for example, where we took real data and we basically built a simulator which is able not only to simulate data which is, or mimic data which is very similar to that data, but also scale it out. So you can basically, based on the prototypical Belgian example, scale out the data to have a country which is 10 times larger, and basically see which kind of events you will get, which kind of processing you need to do, basically which kind of prediction algorithms you need to have to basically deal with such a data stream. We had some from industrial machinery, i.e. Industry 4.0, especially from printing presses. We have data from cars, which was provided by TomTom, actually simulator for car data, not the real data, of course, and obviously also data from social networks, from an extension of the LDBC data generator. And with respect to acquisition and collection, we basically look especially into the extraction of entities, the disambiguation of entities, the extraction of relations from unstructured data. There we use real data, 450 million tweets, to actually build a data generator so that you can either use the tweet data or actually use a generator, which can obviously scale out the problem. And what's also important is we integrated results from previous research projects, especially the Gerbil platform, which has been very successful in the area of machine learning and on text. It's currently being used for natural language extraction, i.e. for knowledge extraction from natural language, but also for natural language generation quite successfully. And those benchmarks are available here to basically scale out. Storage is also super important. That's already been mentioned. We basically looked at how to extend the social network data that we have from LDBC up to a scaling factor of 30, but also make sure that it actually reflects the non-smooth, the dirty data that you actually find in industrial applications, so that one can actually benchmark storage solutions there. And the types of queries are both analytical queries and retrieval queries, basically available across the different benchmarks. And as I mentioned, there are quite a few which are integrated in the platform. Analytics was quite important. So basically being able to benchmark machine learning algorithms, so core machine learning algorithms, classification and regression played a crucial role here. Yeah, we had a collaboration with Big Data Ocean, had roughly 1 million points of ships. And the question was basically classification questions such as finding the destination port, given a trace of a ship, as well as regression questions such as, for example, trying to compute what the potential arrival time of a ship would look like given the trace data which was already available. And visualization and interaction is actually quite tricky to benchmark. So we basically covered areas such as question answering, where one basically has a natural language question and is supposed to generate the corresponding set of answers, either using knowledge graph techniques, but also end-to-end models, for example, neural networks or deep learning, really. Those were all covered or are all covered and basically can be benchmarked using the platform. And that's actually an area where there's quite a bit of work going on, generating better benchmarks, because these systems are being more and more used in industry. And we also obviously covered things like faceted browsing, so basically accessing data, whereas that particular area is quite tough to benchmark. And some of the scenarios still feel a bit synthetic, but that is being worked on. Next steps, I was told that I should still leave some time for questions. Next step, we are basically leading the No Graphs ITN, which is a compendium of 7 universities and 8 companies, which are looking into doing groundwork in the area of knowledge graphs and AI, asking fundamentally the question, how do we actually represent, or how do we marry the different types of representations which are available out there in academia and industry, so that as to gain the pros of the different representations and getting rid of the cons. Nographs.eu, you can find corresponding information there. The platform is going to be central in that particular application. The platform is obviously also an offering of BDV ATF6. So if you're interested in that, please talk to us in the task force. We'll be more than happy to support you. We are porting the platform to Kubernetes now, so that's ongoing work. And we are integrating more benchmarks pertaining to benchmarking things such as embeddings, which play a crucial role in knowledge graphs, but also in unstructured data, machine translation, natural language generation, WebNLG 2020, for example, will be ported to the platform, as well as question answering. Yeah, that's basically what's going on with the Hobbit platform. I think we still have two minutes for questions. Thank you for listening. And yeah, as I promised you, there's a collection of links here, which you can go to if you want more information.
Thank you very much, Axel. So this is an interesting framework. Nuria, will we have an opportunity? Are there some?
I'm checking the chat now, Arne, but I don't see any question yet. I put there some links where people can find more information about the DataBench project. Don't forget that we have a booth also in the virtual space of the WOBA platform. And please don't be shy. At least myself, I don't see now any question in the chat.
Axel, you can stop sharing your screen, perhaps.
I encourage people to participate during the session. Also, if you don't understand anything, so that our colleagues, the speakers, can clarify some of the concepts in case you are not used to them.
If not, I'm more than easy to find online. So if you have any questions, there should be an email. And thank you very much again, Anna, for having me.
Thank you. So then we are moving over to the next benchmark now from China, represented by Funding Gao and the Bench Council community, which have done a large effort in both developing benchmarks, gathering benchmark, and also are supporting new benchmarks under their council. Can you hear us, Funding Gao? And I'll stop sharing my screen so you can take over.
Okay, thanks for your introduction. Can you see the slides?
Yeah, not in presentation mode, but you can put it in presentation mode.
Hello everyone, my name is Wanning Gao from Institute of Computing Technology, Chinese Academy of Science. I'm
So
very
we still see your presentation in kind of presenter mode. If you select it in presentation mode, then we will see only the screen and not the slides to the left.
No, I don't select the presentation mode.
No, but if you do
Down
that,
below,
down to
it's a little
the
screen
right,
down on the bottom.
Okay.
Yeah,
yeah,
there.
do that, because then we see only the slide. Yes, so select that.
Okay. I'm very honored to have the opportunity to attend the forum.
So do you see your presentation on your screen? Do you have two screens perhaps? You can change the two screens.
Yes, because we still see it. We don't see it in presentation mode. It's not a big issue if you want to go on like that.
I think we just go forward.
Yeah.
Okay.
Fine.
I use the presentation mode, but can't you see that?
We see
No.
now the one with the slides to the left. So you can switch the. It's possible for you to go to the slideshow and change it. But you can also run it like that if you
I have
want.
switched to the second page. Can you see it?
Yeah, we see that, but we also see the slides to the left.
Okay.
Arne, I think we just go forward.
Yeah.
Okay. Thank you for the invitation and thanks for the organization of the forum. Today I will introduce Bench Console and Bench Console Big Data and AI Benchmarks. Bench Console is the abbreviation of International Open Benchmark Council, which is a non-profit international organization aiming to promote the standardization, benchmarking, evaluation, incubation, and promotion of cheap AI, big data, blockchain, and other emerging techniques. It has two fundamental responsibilities. The first one is to incubate benchmark projects and host the Bench Console benchmark projects. The second one is to encourage Bench Console-based quantitative approaches to tackle multidisciplinary challenges. Our benchmarking pipeline also follows the 4 steps, including the data acquisition and collection, data storage and preparation, data analytics and machine learning, data visualization and interaction. Take Big Data Bench as an example, which is a big data benchmark suite.
So funneling, we still see the acknowledgement slide. If you're moving on some slides, maybe you have to do something.
Yeah, I have moved to the 4th slides.
Yes, we see the first slides, slide number 1, acknowledgement still.
Yes, maybe you have to stop sharing your screen and start again. You seem to be. Okay.
Yeah, now we see it.
Share and share the screen again.
Yeah.
Can you
see the 4th slide now?
Okay, that's great. So we're taking Big Data Bench as an example, which is a big data benchmark suite where illustrates how we correspond to the above 4 steps. The 4 steps is the benchmarking pipeline in your DataBench toolbox. Big Data Bench provides realistic big data and big data generators for different data types. For example, the structured, semi-structured, and unstructured data types. And provides database storage and access, covering different data processing types like streaming, graph analytics, online service, data warehouse, and so on. Also, we provide interactive analytics and data outputs. For AI benchmarking, Bench Console targets at a wide scope of application domains, including data center, high-performance computing, Internet of Things, and edge computing. Furthermore, we adopt a balanced methodology that considers different benchmarking requirements and provides 3 kinds of benchmarks to fulfill different purposes.
We are still seeing the 4th slide. If you're moving, you think you need to select.
Why those slides don't move? Can we just use the?
Yeah, now it moves.
Okay,
now
okay.
It's on the 5th slide.
We use these slides.
Fine now.
Go forward. Yeah, you're okay.
Okay. We adopt a balanced methodology considering different benchmarking requirements and provide 3 kinds of benchmarks to fulfill different purposes. First, we provide scenario benchmarks for overall system evaluation. The scenario benchmarks are the first AI benchmarks that models the whole execution path and complete use cases of a real-world application scenario. Second, we provide component benchmarks for both workload characterization and ranking purpose. For workload characterization, we provide a comprehensive workload sets with different system and microarchitecture behaviors. For ranking, we provide a subset to achieve the fairness, affordability, and representativeness. Third, we provide micro benchmarks, which are hotspot functions and support code optimizations. So this figure is an overview, and now we go to the six slides. Can you see that?
Yes, we can see the sixth slide here.
Oh, okay, that's great. This figure is an overview and the relationship of our 4 AI benchmarks. We provide AI Bench for data center AI systems and chips benchmarking, HPC AI 500 for HPC AI systems benchmarking, Edge AI Bench for edge computing benchmarking, and AIoT Bench for benchmarking mobile and embedded device intelligence. The balanced AI benchmarking methodology is shown in these slides. We first investigate important AI application scenarios like internet service, and then we single out the typical AI tasks. Further, we choose a comprehensive workload set with a wide coverage of different behaviors and choose a subset for ranking. Finally, we define a layered benchmarking rules. Then the benchmarking results can be fed back to the real-world applications. This table lists the mainstream internet service applications within search engine, social network, and e-commerce. We find there are many involved AI tasks. So from the table, we summarize 17 typical AI tasks. They cover mainstream neural network models like CNN, LSTM, attention, and so on. Also, they cover 5 processing types, including text processing, image, audio, video, and 3-dimensional data processing. These 17 AI tasks and the corresponding models constitutes AI bench training workloads. We define the algorithm, datasets, and target quantity are shown in this table. The 17 benchmarks are representative from the perspectives of microarchitecture level, like the flops computation, memory access pattern, computation pattern, and the system level, such as the throughput, run-to-run variation, and convergence characteristics, and from the algorithm level, such as the model complexity and the architecture. And we also compare AI bench training with MLPerf training, which are concurrent work. Through experiments, we find that AI bench has a wider coverage of model behaviors, system and microarchitecture behaviors, which are shown in this table. And this figure shows the difference from the perspectives of model complexity, computational cost, and the convergent behaviors. Blue one is AI bench and red one is MLPerf. There are also some overlapping workloads like image classification. We find that AI bench workloads covers more distinct behaviors. And this figure shows the microarchitecture comparison. We also find that AI bench achieves comprehensiveness, which is useful for chip design. We define a layered benchmarking rules to assure the fairness, which consisting of hardware, software, and the free levels. Different levels have different permissions for the modification and adjustments. For example, the hardware level allows the modification of hardware, operating system, and the hyperparameter layers, while the other layers remain unchanged. For ranking, we choose a subset from the 17 workloads within AI Bench, aiming to use a minimum set to represent the maximum workload characteristics. The subset should also have widely accepted evaluation metrics and good repeatability to assure the fairness of ranking. We evaluate the run-to-run variation of 17 workloads and find that some of them have no variation like image classification, while some of them have high variation like image compression. This data provide useful guidance on how to choose the subset. To achieve the wide coverage of diverse characteristics, we adopt k-means clustering and classify them into 3 clusters, combining the repeatability, affordability, and representativeness. We finally choose 3 workloads for ranking. They are image classification, object detection, and learning to rank. And we also find these 3 workloads are clustered into different clusters. And we released the intelligence chips ranking list using AI Bench subset. For image classification, TPU performs much better than GPU. However, we find that for object and object detection and learning to rank, TPU has a poor support for these 2 workloads, which lose some generality. Next, I will introduce the HPC AI 500 for benchmarking HPC AI systems. For high-performance computing benchmarking, we focus on 5 metrics, and we find that AI Bench subset nearly satisfies the above all metrics because the AI Bench are selected according to the representativeness, affordability, repeatability, and computation characteristics, and so on. So AI Bench subset nearly satisfies the above all metrics. We compare the computation complexity of AI Bench subsets and find that learning to rank has extremely low flops than the other 2 workloads. So we choose image classification and object detection for high-performance computing benchmarking. Analogously, we also define a layered benchmarking rules. Different layers specify different aspects, like the communication layer in layer 3. We also adopt a new metric which considers both computing complexity and model quality called vanity flops, which we incur a penalty coefficient for the penalty of the loss of accuracy. HPC AI 500 includes 2 workloads: extreme weather analysis to identify various extreme weather patterns and image classification. The datasets uses the extreme weather datasets and the ImageNet. HPC AI 500 is the first AI benchmark for high-performance computing that uses the real-world scientific datasets. And this table shows the workload details, including the target quality, number of epochs, frameworks, and libraries. Using HPC AI 500, we released the first high-performance computing AI ranking list using image classification workloads. Fujitsu ranks first, achieving 31 valid P-flops. The hardware consists of 2,048 NVIDIA Tesla version 100 GPUs. Google ranks second, achieving 20 valid P-flops. The hardware consists of 1,024 TPU version 3. Sony ranks third, achieving about 10 valid P-flops. The hardware consists of 2,176 NVIDIA Tesla version 100 GPUs. And this net shows the training time and the model quality of the high-performance computing AI systems. In summary, Bench Console benchmarks have been released and open-sourced on our website. We also provide corresponding technical reports for each benchmark. We will periodically release the ranking list on our website. Thanks for your listening. If you have interest on Bench Console or benchmarks, welcome to join us. Thank you again.
Thank you, Fan Ling. So you are running also this in an international context. There will be a Bench Council conference, because it was supposed to be in Atlanta next week, but that will become a virtual conference. So this is an opportunity to join. We will, in saving time, we will not take a lot of questions online, but enter questions, and we will do that in parallel. So now we need to move on. Let's see, I can just show for my screen here. So you see the next presentation. We are actually moving on internationally and moving on to India now, to Rekha Shinghai. And she has been working also in the national context in the spec community and linked to MLPerf and other international benchmarking communities on big data and AI. So I will stop sharing my screen and let you take over, Rekha.
Share my screen. Can you see my screen?
Yeah, I see your screen.
Okay.
And
Yeah,
if you select presentation mode like that, yes, good. Thank you. Please go on.
Yeah, thanks, Anne, for the introduction, and thanks, Todor, for giving me opportunity to speak in this forum. I have been working with Todor quite some time as a part of Spec Big Data Group. So today I'm going to talk about definitely about MLPerf and A-Bench, as Anne has mentioned, but I titled my talk as a framework for benchmarking ML and DL workloads, because I'm coming from industry. We do have our internal benchmark for MLDL workload, which I will share in this forum, although they are not in the open source. So that is why I changed my title beyond ML, Perf, and A-Bench. So I'm working as a senior scientist at Tata Consultancy Service Research. My focus has been at the intersection of ML, DL systems and performance. So in that regard, I have been looking into a couple of machine learning benchmarks and part of ML, Perf as well. So the kind of ML perf or ML pipeline which we explore in industry as well, we start with the data exploration, data pre-processing, data extraction using SQL, do some feature generation, model tuning, and then the deployment of the whole pipeline, including inference and all, right? So in each of these space, when we explored, I find a couple of benchmarks already available. There is an ID benchmark, which is available in the data exploration phase. I think this benchmark is coming from the University of Toronto. Then there is a benchmark specifically for data pre-processing from academia, ADA bench. Again, for the data extraction, where you have a lot of joins across heterogeneous data sources, and you have some kind of SQL query going through it. So you have Big Bench, also the benchmark coming from the spec group. Also, there's a Polystore benchmarks, which allows you to write your data in a declarative manner through SQL and fetching it from a different data model thing, right? Yeah, maybe relational or SQL. Then feature generation, which is very specific to your data set and your problem statement. So we don't find much any benchmark in this space. However, we do have something which I will share with you as an industry. Then we have model tuning and building, which MLPerf falls into this domain. And again, the deployment of the whole pipeline, which Todor and I worked on it, and we referred as an A-Bench. So in this talk, I'll focus more on these two, apart from what we have done it. So what are the new challenges which we also feel, coming forth because of this new MLDL workload? Because we did have big data workload earlier, but because of this machine learning, deep learning, the challenges which we also face, and I'm sure academia also faces, is now your MLDL workload are deployed on heterogeneous hardware, which may be having CPU, GPU, TPU, ASIC, all combination. So how do you really benchmark this? How do you write it? Because, and even FPGA I want to include here, and then your programming and the writing the code itself will be very difficult. Also, you have a challenge of having the same application being written in many frameworks. So how do you benchmark across different frameworks, which has their own nitty-gritty in terms of parallelization? Again, then people may have a heterogeneous big data technology in the pipeline. There is a numerous big data stack, as been spoken by earlier speaker as well. So how do you really take care of it in your benchmarking? How do you evaluate? And there are connectors across different technology as well, which we looked into a bench. I'm going to share that. And apart from it, there are many kind of NN model, even for the same problem statement, which could have RNN model, CNN model, LSTM. So how do you really benchmark for a particular business scenario? So these are different challenges which we also faced it in industry. This is one of the benchmarks which we have built internally in our organization. However, it is not in the open source, but I can share it with you. There's a little bit different than what academia has been doing in this space. This benchmark is in the recommendation application, and we call it as a configurable benchmark because we make use of domain meta model to do the feature engineering automatically. And so we capture the data from users interaction, which could be a transactional database or could be movie rating for each user. So user interaction database, very generalized. In our case, we looked at multiple kind of transactional database as the interaction data set. And we take up domain meta model, which could be retail domain or hospitality domain, how the users interact in the domain in terms of users, entities, context, actions. So that kind of meta model, we capture it and automatically generate features and do some data pre-processing on that features to further build the fine-grained features like aggregation, windowing, min-max. And we store all these features in a feature store. So it is a little different than the normal pipeline. We do store in features in feature store and make use of the data in the feature store in a real time while making an inference, right? And then this, after the feature are put in the feature store, models are built, machine learning, deep learning, reinforcement learning. We are looking at all kind of modeling techniques, and then model being deployed and do some kind of monitoring of the model. So this is the whole pipeline which we have built, and mapping it to what NA has started in the beginning, the four chunks of the ML pipeline. We have used different technology stacks to evaluate this whole pipeline. We started looking at Spark Scala and Spark Python for data acquisition and collection. We also looked at Ignite, which is an in-memory store. Since I mentioned that we have a feature store, we were looking at the big data technology, which allows me to store my features in memory. So at data acquisition collection, we explored these three technologies. And data storage preparation, we explored MongoDB and Ignite with all the possible combinations. And data analytics and ML, we did the training in Python because our focus in this benchmark was more on the MLDL inference. And we use Tornado, which allows you to Python-based model inference in parallel. So that's the kind of technology stack we evaluated. The detail of this benchmark, we have published it, although they are not in GitHub. But if you want to know further detail, what kind of performance we observed with different kind of combination of this technology stack, they were published in ACM COMET 2019. So you please feel free, because of a shortage of time, I will not go in further detail. But this is the kind of work we did in our organization in the recommendation space. And we're also doing in supply chain, which I'll cover in the conclusions slide. Now coming to A bench, which is also on the same premise, looking at the whole pipeline deployment. So the motivation came actually, and this work is also published in ICP 2018 with Todor. The idea behind this A bench is what we observed. Since I mentioned, we have numerous big data technology stacks and different connectors. During my experience at my industry in the recommendation benchmark, we observed the connectors across different technologies are playing a major role in giving the overall performance for your workload. So what we thought, can we have a benchmark which can give the performance of the whole technology stack rather than individual technology, including the connectors across the technology. So that was the idea which we started working with. And in that idea, we thought of, let's have a benchmark synthesizer. We didn't plan to invent a new benchmark. There are so many benchmarks already available, which we call it the benchmark repository. And user can give its own specification that what kind of workload he's looking at, what is the architecture he's looking at, data generation configuration, what data model he wants to generate, the types and size, what benchmark metric is looking at, deployment, whether on the cloud using Kubernetes or on the prem machine or the hybrid configuration. We allow the user to give all this configuration, and benchmark synthesizer will generate the benchmarks based on the user requirement and available benchmark, and the driver will actually map the required configuration on the cloud and on the container form and give it back to you some results. So that was the idea behind A bench, which we worked on it. It's not fully functional yet. I and Todor are still working on it to bring it to the maturity stage. Now coming back to MLPerf, so MLPerf, as I think most of you may be aware, it started from the DataBench, which was launched by Stanford and an academia, a PhD student called Coleman. He started looking at the DataBench, which finally evolved into an MLPerf. Now MLPerf has both academia and industry participation in this, and they focus both on inference and the training benchmark. So the goals of MLPerf, so all these, let me put a disclaimer, these are not my own slides. I have borrowed it from the MLPerf community. So whatever has been put up here from my presentation, it's all aligned with what MLPerf has been sharing in the public. So MLPerf goal was basically to start making some progress in the ML domain, and they wanted to serve both commercial and the research communities. So participation is also from both the communities now. And they wanted to improve the ML innovation. So they have a concept of open and closed innovation. In the closed innovation, they have a fixed type of model where they accept the submission from different vendors. In the open submission, they allow even the innovation within ML, because there are a lot of new algorithms coming up for the same image recognition, taking care of sparsity and some new innovation. So in the open category, they allow those kind of submission as well. And they have some strict guidelines to ensure that anybody can replicate these benchmarks, so that you can be really fair on that front, right? So the kind of benchmark which are available in MLPerf, this may be pretty old, I don't know, because I think maybe a year-old kind of slide, maybe more would have been added by now as we are talking. So the problem area, they have been looking at the vision, language, audio, commerce, and the action-based thing. And within each one of them, they have many kind of problem statement. For each one of them, they have benchmark, and the data sets also, which they have been working on, have been clearly specified. And this is the closed kind of submission where they specify what model one has to look into it, and the metric which they are looking for each of those benchmarks. So they look at the, I'll come to that. So the kind of metric they look at it, not just accuracy, not just performance, their focus is on both performance as well as the accuracy. Performance means the training time or the inference time. So the metric is basically time to accuracy. So that's what they call it, initially called by Cole Coleman in the DataBench release. So that's a very interesting metric where you will capture both the time, and now they've started including cost and the power as well, because the focus has been coming on power on the mobile devices and the edge devices. So that's what the MLPerf community has been doing it. I may not go in detail from the time constraint, and I like to conclude my talk here by putting the pipeline here and telling you what we have been doing in industry. So we have been looking in the recommendation space and supply chain space, both MLDL algorithm and reinforcement learning algorithm at the level of data acquisition, storage preparation, analytics, and ML. So our focus has been more in these three category of the whole pipeline, and come out with a different technology evaluation to get how they perform in different scenarios. So with that, thank you very much. I like to stop here. Thank you.
Thank you very much, Arne. Just a comment for you. You have 5 minutes to finalize this first session. I think it would be maybe very good if you could explain a bit why these benchmarks.
Actually, Tudor is exactly what he's going to do.
Okay,
so that's exactly what we will do.
Go forward.
Tudor, I'll drop the introduction of you, and you can take over for exactly this now, Tudor.
Yes,
Tudor has also been working with with Reka, so you can also connect to that. So please share your screen, Tudor.
Maybe from the audience, it would be very good if you could tell us in the chat if there are some additional benchmarks that you would be interested in seeing here, but for some reason you missed them here. If you know the ones that have been presented or not, it would be good to get a bit of interaction and opinions from you in the chat. Thanks a lot.
Okay, so yeah, I prepared a few slides to wrap up, and of course I'll go again back to the pipeline that we already saw multiple times and that we developed as part of DataBench. And the idea of this pipeline is to guide and help people who need to implement new architectures and new systems to be easy to both find the right technology and also the right benchmark among all the existing one. So what we did is we first also mapped the steps to the BDVA reference model, as you already saw, as Arne already showed. And here are some of the steps in the BDVA reference model that we aligned with the pipeline, as you can see. So the idea is that these steps really can help you to, after this, more specifically search in the case of technologies. Here I give as example the big data and AI landscape, where we have also categories of different technologies. So using these categories here in processing, you can search for particular technologies in the big data and AI landscape. But also what you can do is you can search also for benchmarks, and this is something that we prepared as part of DataBench. So since we have this mapping between the BDVA reference model and the benchmarks, you can also easily navigate and search for them. And not only this, you can also, if you're a project or if you're working on creating your own infrastructure, you can use this to find the best technology and benchmark. And now I'll go in a bit more detail. So here I try to illustrate some of the benchmarks that we heard about today. So the first group are the one from the bench console, which we already heard, and I tried to map them here so you can see. So we have them in the DataBench tool also mapped in the different categories. And also from the Hobbit benchmark platform is here, and also some of the linked data benchmark console benchmarks, also A-Bench and MLPerf. And additionally, in the next session, we'll hear some of the projects, how they build their architectures, and they use some of the benchmarks, and how they pick these benchmarks. So in summary, what we did in the DataBench toolbox, you can find this mapping between the pipeline steps and the benchmarks. And in this matrix, you see for each step, we have categorized it according to the benchmarks. So you can pick based on the step you're implementing, you can search for the most appropriate benchmark that can help in your implementation. Yes, yeah, this is the short summary that I prepared. Arne?
Thank you.
We have any questions?
I think that was a good overview. Is there any questions or anything? We have a few minutes.
In fact, it would be good to know if people can see my messages in Wova, because I'm a bit surprised that no one is reacting. Maybe you're still a bit sleepy. At least to know that people can read them.
Can I ask if a question, Axel, here?
Yeah, excellent, please.
I don't completely understand the classification on the slide before. Why Hobbit is considered an LDBC benchmark? I'm pretty sure I misunderstood something. I just don't know what I misunderstood.
Yeah, I guess it is in the DataBench toolbox. It's classified in all various areas, since it's actually is a benchmarking framework that covers various things.
Okay.
Yes, it's separate. It's not. It's just I put it in this category, but it's separate, of course.
Okay. Cool. Thanks.
Yeah. It's not.
How useful it is for benchmarking communities that your benchmarks are integrated in the DataBench toolbox. Did you see it as a benefit for you?
Me, absolutely, of course. So basically, the whole idea is to make benchmarks available in as many ways as possible. So it's great to have basically a view on benchmarks, which we did not have in the project, which is basically the more business-oriented view. So it's fantastic.
Yeah, comments from the others.
You can maybe unshare your screen, Tudor,
yes,
and then I will.
So then, Arne, I think that if you want, we can jump directly to the next session if we don't get any question on this, and people can still post their questions in the chat, so no problem about that.
Yep, no, certainly. So I will share my screen again.
I understand that you have also the speakers of the next session. You don't need me to show them? Okay.
No,
perfect.
I had that, so that will be fine. Here.
So just for the people that are attending the seminar now, we will go to session 2, which is in part 1. So this is the one before the coffee break. And basically you will get a different.
Okay, so then we move into session 2, where we take a project perspective on big data architectural pipelines and benchmark opportunities. So you have seen this 4 high-level steps of the big data and AI architectural pipeline. There are other aspects and dimensions to this, because across these steps we can talk about batch processing, real-time processing, and interactive processing. So there will be different paths through this pipeline, but we still see those as elements in the majority of the projects and activities we have, because we typically will have to go through these steps. There are also variations on focus on data types, dealing with imagery and image analytics, have variations dealing with sensor data or dealing with the natural language processing. So this is a way of looking at both the path through any, say, big data and AI system, to relate benchmarks to this, to look at available tools and components, also to look at standards, and this can also be handled across the computing continuum, going from the edge to the fog and to the cloud and to HPC, as we have seen. So what we have in a number of the ongoing projects and activities that we have worked with, we see that there are concrete realizations of these steps that depends a bit on the data types. So here's an example of IoT real-time data pipeline. Another data representation for graph data here with knowledge graphs and ontologies. There is a different implementation strategy of the patterns, but still for all of the same steps in the overall pipeline. And what we will see next are examples of these realizations from different projects. We already see that there are related benchmarks to the areas, but we can also identify patterns of reusable common architectures. So we have a set of we call blueprints, where we have looked into the aspects of different patterns here for batch, for interactive, for real-time, different storage types, also different types of analytics that again follow these steps. And as we are looking into the steps and realizations, we can also look into actual implementations, looking at components that are being used in an architecture. So this is what we will see next when we go through 5 projects that have been realizing big data and AI-based systems in a project setting. They will also relate to what they have been doing in the different areas, also in their architecture. These are things we can further find in the DataBench toolbox. So here we see a part of the toolbox where you can also search by looking into the pipeline and the blueprints and identify these patterns as well as benchmarks. So in that context, which we're using as an overall umbrella for both the benchmarks and for the various projects, we will now go through 5 different projects that all have been working in big data and AI context as follows. And for this, we have now a number of panelists that will present, and we will start according to the plan here with the IBIDAS project with Leonidas Kalipolitis. He is technical manager at Aegis IT Research and have been involved in this project, working in particular on evaluation schemes for and user perspective on this that we will have presented. So I will leave now Leonidas to give a short presentation of the IBIDAS project. So I'll stop sharing my screen and you can take over, Leonidas. You are muted, Leonidas.
Yeah, now it's coming. Leonidas, I think we see your slides, but we don't see it in presentation mode as it happened before.
Okay, yes,
it's
good. Yeah,
we can hear you now. Good.
Okay, so probably the multi-screen setup doesn't really work. So I'm gonna run it from here if it's not a problem,
Yeah,
just to save some time. Okay. All right, so just a quick overview of our project Abidas. So it's a RIA project with 3 years duration. It started in January 2018, so it's coming to its end on the next month with a budget of almost 5 million and 33 partners consortium. Just a quick glimpse of the partners. You can see we have partners are quite all over Europe. So we have fourth from Greece, Barcelona Supercomputing Center, IBM Israel, the Research Center of Fiat from Italy, SAG, CaixaBank from Spain, University of Manchester, École de Pons from Paris, France, Atos, Spain, EGIS from the UK, ITML from Greece as well, and University of Novi Sad in Serbia, and Telefonica from Spain. So quickly going through the key messages of the project, what Abidas was trying to do is to deliver a complete and safe environment for big data experimentation and offer this as a self-service solution that would help breaking silos and boost the EU data-driven economy. And of course, increase the impact in the research community and also to industrial innovation capacity. And towards these goals, we developed a set of tools and services to increase the quality of data analysis, the consolidation of realistic and fabricated data, and also to manage the various infrastructures. So this is the project's pipeline. We have the different modes of users on the left side, where we allow experts but non-experts as well to use our platform. And we have also the co-develop mode. We have these 3 operational modes, as we call them. We also give the opportunity to not only use real data, but to also fabricate data and tokenize data, a solution that allows us to enable breaking silos and share data, use data by overcoming privacy restrictions. And we also have streaming and batch analytics for these 2 types of incoming data. And finally, of course, the visualization of the results and sharing of the underlying models used to analyze the data. So this is a matching to the DataBench pipeline. On the top, you can see the experimental workflow of Abidas. So we have during the project setup, and the data selection, we can say that we do the actions that are listed under the first step of the DataBench pipeline, the data acquisition and collection. Then we have the data preparation, matching to the second step, the experiment execution, as we call them, which is actually the actual analytics pipeline using machine learning techniques mostly. And finally, the results visualization, where we help the users interact with the results and maybe also extract some useful insights. And I have included an example of such an experiment from the banking section. So for this one, we had both batch and streaming data incoming. This includes data collected by different sources like ATMs, online banking services, actions performed in the employees' workstations, etc. We then use this data to anonymize and decrypt it so that we can use them without revealing any personal data and preserving privacy. And then we executed some experiments having to do with clustering of the data and graph-based analysis. And finally, resulted in visualizations of charts and interactive graphs and results of the analysis to the incoming streaming data. Okay, so this is just a quick look of the architecture of the project. I'm going to go fast through this. So we have the interfaces using the technologies provided by the partners. We have the batch processing and the machine learning analysis based on models and programming concepts by the relevant partners. We have the streaming analytics and GPU accelerated analytics provided, and also, of course, the resource management orchestration and the whole platform integration that makes all this working pipeline. And now I'm gonna quickly go through the benchmarks that we try to map with our tools. I'm just going to highlight the ones that actually try to use benchmarks that can be found under the DataBench catalog. So we have QBeast from Barcelona Supercomputing Center, which has the role to assist with the multidimensional index and storage in Ibidas, and is using the TPC-H benchmark. And regarding the machine learning algorithms based on the COMS environment in Python, for batch analytics, we have the as benchmarks, the respective API implementations, sklearn, also HiBench, which is also one of the listed DataBench benchmarks. I'm also going to talk about the business data and analytics level and the type of analysis and process that we have done. So you can see on the left side, these are the three domains that Ibidas deals with: telecoms, finance, and manufacturing. Business objective for telecoms is to improve and optimize operations with data sets sized in terabytes, both batch and streaming modes. And the analysis that we were looking for there was predictive as well as descriptive and diagnostic from historical data. For finance, again, we want to improve decision making. We used tokenized data sets in the size of petabytes in both batch and streaming modes. And there the analysis was mainly descriptive or diagnostic. And finally, for manufacturing, again, the main goal is to improve and optimize the current operations. Data coming from SCADA and MES and MES used in the manufacturing field, and in the size of them is in the magnitude of gigabytes, both in batch and streaming. And again, we are using them from predictive and diagnostic analysis. This is again a business level benchmarking with the most relevant business KPIs for all the use cases. So we can see that for telecom, for Telefonica, mostly processing costs and customer satisfaction are the most important KPIs. For the finance section and Kaisa, all the use cases were mainly targeted to cost reduction and time efficiency. And for CRF, which is the pilot for the manufacturing sector, we have the cost reduction again, which is common to all the cases you can see, and mainly the increase of the product quality in the produced products. I think that's it. I think I'm on time. If you have any questions, I'm happy to answer.
If you can share your screen, we'll be able to introduce the next. Meanwhile, please enter questions in the chat. We will handle that asynchronously, so that you will be able to get that answered. But we will also continue running the program so we can keep up the schedule. So the next project to be presented is the Day By For You project that will be presented by Brian Elveseter from SINTEF, who is also the technical coordinator of the project. So I will let him introduce that himself. So I'll stop sharing and you can take over, Brian, and present.
Okay, can you hear me?
Yep.
Yeah.
I can't see myself.
We can't see you
No,
either.
in fact, we see the
just the
blue
background.
Yes, I don't know what is.
Okay, well, that's fine. As long as we can see your presentation, if you can share that, we'll see.
See if you can share your screen.
Yes, okay. Share my screen. Share.
Yeah,
You see
it
my
starts
screen?
now. Yeah.
Yeah, now we see.
We see. So you just put it in presentation mode.
Yes, wait. Okay.
Perfect.
Yep. Let's go ahead.
Okay, so as Arne said, I'm Brian Evesæter from Sintef, so one of his colleagues, and I'm currently the technical manager of the Day-by-For-You project. So first I give you a short introduction about some facts about the project. So it's a Horizon 2020 innovation action. It started in January 2018 and it's now near its end. So it will end in December. So the main goal of the project is to develop big data tools for public procurement, meaning that we develop tools for data access, analytics, interaction, and visualization. We have 10 partners from 5 countries, and here you see the list of partners and the countries that they are originating from. So one of the main technical results of the Day-by-For-You project is to create a knowledge graph of procurement and company data. So in the project, we have 2 partners, Open Ops and Open Corporates, that are responsible for collecting a lot of public procurement data and company data. And these are then 2 main sources for the data that we need to incorporate into our knowledge graph. I did a check just yesterday. So we decided to onboard data from January 2019, and it's ongoing on a daily basis. So from January 2019 to October 2020, we have the source data consists of 8.8 million JSON files that we have downloaded, and they are approximately 16 gigabyte in total size. So from OpenOps, we download public procurement data, that is tenders and awards that are made for these tenders. In the awards, they list suppliers, and we want to get more details about the supplier. And here we use Open Corporates in order to download additional company data when we find a match for the suppliers. So we do this as a batch processing. So we have developed an ontology. So we mapped the JSON data into RDF according to the ontology that we have developed. And we use a reconciliation service from Open Corporates in order to match the supplier name in the awards with the company data that they provide through their API. In this batch processing, we process around 3,000 files per day. And that is then mapped into RDF using our ontology and published into a triple store. So when I did the count yesterday, the current data that we have consists of 139 million triples. It contains 1.46 million tenders and 1.72 million awards and around 103,000 companies. So that's one of the core technical results of Day-by-For-You. And we have, of course, built an architecture around that. So the Day-by-For-You platform, here you see that we have the ingestion from Open Ops and Open Corporates being published into a triple store, and we also then provide various APIs on top of that. So obviously we have a Sparkle API so that you can query the knowledge graph using Sparkle, but we also know that end users, they might prefer a RESTful API, so then we also provide a core API that is wrapping the Sparkle queries so that end users can only deal with REST and receive the data as formatted JSON. We also store all of the JSON files in the document store in order to support cross-lingual search so that you can search for expressions and terms in, for instance, Spanish and English, so that when you search for, you can search for the Spanish term and then you might get hits in English description in a document. Now let's move to in Day-by-For-You, I've been involved in 2 different benchmark cases. So one is the data ingestion, and as you can see, this maps in the architecture to the data acquisition and the data storage preparation phases. So here is we implemented the data ingestion in Python, and we used a third-party tool called RML Mapper in order to do the mapping from JSON to XML and then to RDF according to the ontology. And for each of these steps, basically there's a set of files that are being input and output. So in the first step, the download procurement data, we download all of the JSON files from OpenOps. And then in the next step, we reconcile the supplier data in the awards and then download the data for companies from Open Corporates. Then we mapped, we need to fix some problems with the JSON data, so we need to enrich it. And we found that using this RML mapper, it was easier to do a conversion from XML to RDF. So then we convert the JSON to XML and then do the mapping, and we publish RDF to the database. So obviously, it's very important here to do some benchmarking in order to find bottlenecks. So here you can see that 2 of these steps takes a considerable amount of time. So in the second step, on average, it took between 30 minutes to 90 minutes per day. And for the 5th step, it took around 1 hour per day. Obviously, for the 5th step, we're using a third-party tool. So there we could, of course, have experimented with using a different tool. But the focus for improving the performance of this data ingestion was on the 2nd step, where we wrote the Python code. So basically, by introducing a native way of a proprietary way of doing benchmarking by logging performance for each step, we decided to implement caching for the 2nd release of the data ingestion pipeline. And then we were able to reduce the duration for the 2nd step from over 1 hour per day to less than 20 minutes per day. And here I give an example of such a log file that we collect for the 2nd step. So this is an aggregated example, aggregating the number of award for the month of March 2020. And as you can see, it contains nearly 19,000 awards, and it also contains, we do close to 75,000 lookups for supplier names. And by introducing lookups from the API, you see that that takes approximately 2.3 seconds for every lookup we do. But here it's close to 40,000 or 39,000 that we are able to find in the cache. And that actually translates to around 25 hours saved just for this processing step for month March. So this was a way for us to actually improve the data ingestion pipeline. The second benchmarking case deals with query and visualization. So that is related to the data storage and the data visualization in the DataBench reference pipeline. So we were particularly interested in Sparkle query performance. And that has also to do that in the core API that we developed, it's basically wrapping Sparkle queries and providing them through a RESTful API. And we also did some visualization. So an example of a visualization on the data day-by-for-you.eu page, we provide some statistics, and then as we can see here, we query some Sparkle, execute some Sparkle queries, and then we visualize statistics. So here is one showing the number of tenders per jurisdiction or country, and this is visualized in a geo chart. Related to the benchmarking, we had some questions that we wanted to get answered. So basically, which triple store should we choose? We also deployed this database on Amazon Cloud. And of course, here there is also a great degree of price difference when it comes to the resource plan that you can choose. And of course, we don't want to pay too much. So that's also a question that we wanted to get answered in the benchmarking. So which plan should we choose to get appropriate benchmarking or performance? And also the benchmarking could also help us identify database stability issues. So one thing that we encountered was that we needed to tune the Java virtual memory heap size, or else the databases would crash. So that was also things that this benchmarking could help us with. So in searching for benchmark to do some RDF query and Sparkle query performance, we used the DataBench toolbox. So this, of course, provides a guided search. And then for the platform and architecture features, you can then look at storage types. And there you get links to various benchmarks that are related to graph databases. So, and we decided by reading through the descriptions of the benchmarks that were available in the DataBench toolbox, we decided that the semantic publishing benchmark seemed like a good candidate. There were various reasons for that, but we had initially decided on using GraphDB in Day-by-For-You. And we also saw that this benchmark supported native GraphDB queries, and it also provided a generic benchmark for Sparkle 1.1 based databases. So we have currently benchmark GraphDB that we used initially, and then we moved over to Apache Jena Fuseki with the Jena TDB database. And we're also considering to do a benchmark on V2 also. So that's basically that from my side. So any questions?
Thank you, Brian. If you can release your screen, that's good.
Arne, just a comment, because we had a question for Leonidas, but it was posted just when Brian started his presentation, so I decided to wait now. Leonidas, in the chat, someone is asking how the SCADA anonymization exactly happens in manufacturing sector benchmarking. So I suppose this means how
can you unshare your screen, Brian?
Anonymization.
Okay, thank you. Yeah, thanks. Yeah.
Or maybe
Yes, yes, so I was actually preparing a written response to the chat, I saw it, but just a quick answer would be that mainly what Fiat used to preserve privacy in such kind of data was mainly masking as an anonymization technique and some tokenization algorithms, and also hiding the sequence of products. I mean, the data that we were getting were referring to a production line of a specific product. So what they did was they masked all the attributes, they tokenized some of the values, and also modified the sequence of products of data and the measurements, and also the timestamps. So just this is a brief, let's say, overview of the techniques that they used for this kind of data.
Eleni, I hope this is fine for you. If not, you can put it in the chat, and maybe Leonidas can answer a bit later with more details. And just a question also for the other panelists. When you make your presentations, it would be good to understand also if you still see some shortcomings or some challenges that we in DataBench could include in our toolbox. I'm really happy to see from the Brian presentation that they have already used in Day-by-For-You the DataBench toolbox that we have created and will be shown afterwards. But it would be good for us to understand exactly if some of the benchmarks we have integrated are not enough, if you are missing something that is particularly important, if you see some problems in terms of finding the right infrastructure to run the benchmarks, how this can be solved. I don't know, anything that helps us also to improve in the last part of the project, because of course what we would like is to do something that is widely used by the projects and by companies in general. So it would be good if in your presentations you could also provide us some hints on how to improve in the next months we have ahead of us.
Yeah, and of course, further as the toolbox is available, we will also encourage other communities to start using it. And we have set up some resources now to interact with the community on this and to support you. So this is not only the panelists, but everyone listening. Yeah. We are now happy to interact with you. Sure. Okay, thank you. We move on to another project, Track and Know by Athanasios Komparos, who has been working in this. And we present it a bit from the user side and from the architecture. So I'll unshare my screen and let Athanasios start sharing and introduce the Track and Know project perspective.
And Arne, I'm really sorry because I saw that Axel also posted a question, but he did it in the chat of Zoom, so that's why I didn't see it before. So you may want to go to that one. It's specifically a question to Brian. How did you deal with the uniformity of SMB? And did you benchmark results that reveal any interesting insights? So this was for Brian.
Okay. So I'll answer on the chat.
Yes. Meanwhile, do we have Athanasios ready here to talk and share his screen?
And yeah, and I think that Richard, you have to promote Athanasios as presenters. Apparently, he is just attendee. That's what he's saying also in the chat.
Okay. Athanasios. It's Athanasios.
Yeah, do you see Athanasios Komparos?
Yeah, the complete name is Athanasios.
Athanasios, okay. Okay, done.
Okay.
Okay, now we should be able to do it.
Sorry, Athanasios, didn't notice you were in the attendees.
You are the floor is yours.
Hello, can you see me?
Yep.
Yep.
Okay, let me share my screen. I think you can see my screen right now.
Yeah, perfect. But as in the other cases, we don't see it in presentation mode in case you want to check.
No, it's perfect. It's
now
good.
It's perfect.
That's kind. Okay, okay. So thank you all. I'm really excited to have me here. I'm Athanasios Komparos from Vodafone Novus, and we are piloting a fleet management case under the Track and Know project. Today, I will be discussing a little bit the history of fleet management at Vodafone Novus, then the pipelines and how it's been integrated with Track and Know, and where are we now, and the next steps we're going to follow. So just to get a head start, the fleet management application that we are having, it has been developed almost 11 years. Since then, many things have changed. With our participation in the Track and Know platform, more things are changing and much faster. Currently, the Track and Know, the fleet management platform, has been active with nearly 13,000 active vehicles, at least. This is a number that it's been changing with every passing month. We have been working on this project for 11 years, and we still have it as our flagship project. Our project is based on customer needs, and especially for the fleet management of truck carriers and big fleets. The IoT platform that we have developed, it's pretty much a standard platform where we use the network of Vodafone partners in order to have our vehicles communicate with our platform. Then there is a load level device system which interacts directly with the device. As the data arrive from the device, we do an online data processing. Once data reside in the platform, then using the GUI most of the times, or scheduler tools, users invoke offline analytics, and then via an API or a graphical user interface, we give this information to the end user. A little bit on the reality of the fleet. You may ask where the devices are installed. The devices are installed most of the times under the hood of the vehicles. And currently we receive more than 3 million data packets on average by day. Of course, this is not during the 24 hours, but during peak times, we may have more than 2 million data packets within a few hours. This data is pretty much GPS-based data and some sensors in some cases, like the fuel, like temperature of a cooling vehicle, and so on. What are the challenges that we have and how Track and Know project is going to tackle those challenges? Well, the initial challenge is the data itself. Because of the GPS network is not the best network in all locations, we have sometimes a low signal strength. This is mostly due to the installation since the device is under the bonnet. In urban areas where we have bridges, tall buildings, we have reflections and other issues. Also, the vehicles sometimes do not have a good power supply to the device, and the electronics are aging, especially for vehicles more than 15 years. So these kind of technical issues create problems to the real data that we receive from the platform. So once we have these problems, what the user gets as a problem, we have some incorrect position on the map, we have alerts falsely, or we have location gaps during displays of the routes. So how to tackle those things? Well, this is mostly where the Track and Know pipeline comes into place. One of our major concerns was the quality of the data as they arrive from the devices, how they are being managed inside Track and Know, and how they are being released to the end user. At first, we collect the data via the sensors, then most of the data is being categorized and curated on the Kafka streams, where most of the application is based on Kafka streams, which really make it easy for Vodafone Novus developers to integrate with all the toolboxes. Shortly after the data are being stored in a NoSQL stores, then we can run offline analytics, like some clustering, or we can identify mobility networks. Whereas during live data accumulation from the device, we do pattern recognitions on the data and some location forecastings, which I'm going to display later. Finally, we visualize the data either with visual analytics tools or simple end-user GUIs like a mapping, which have the latest information of the vehicle. So how an existing IoT platform related to fleet integrates at a logical level with the Track and Know. The online processing has been updated. In fact, we plug in a Kafka stream through our online processing stream directly to the Track and Know platform. The output is being pushed again back to the fleet management platform. Before this process takes place, the Track and Know does data cleansing, data enrichment. We have a data pattern recognition methodologies. We use in some cases future location prediction, and in really early stages, we do some driver behavior analytics. This is exactly the part where we are mostly interested, because the mass amount of data that keep coming within a few minutes is really important for us to know its benchmarking and how to actually improve the online processing steps at first. And then when we have already the data, which is curated, cleaned, and ready for extra processing, we are running the offline process, which identifies the individual mobility networks. We try to predict the next possible service of the vehicle based on where the vehicle has been and where it's probably going to be. We have analysis of hotspots where there are areas that vehicles should avoid. We do some trajectory matching in order to identify commonalities between trajectories of vehicles within one customer. And of course, we have the visualization. The most important tool that I'm going to discuss a little bit is the online process where the streaming data coming from a Kafka platform before going to the VFI fleet management platform are being cleansed. Some of them are being matched in order to exclude data that are not properly on the map and enriched with either poise, weather, or other features. This is the first place where we do benchmarking, because the duration of this pipeline actually is the duration of the whole processing of the platform, which means that once a packet is arrived from a vehicle, the time between the arrival of the packet and the presentation to an end user or to an alert mechanism should be as minimum as possible. Just for a presentation idea, we have two test cases of what the before mentioned processing pipeline actually does. In the first case, we have vehicles that are moving, but due to the sampling rate, they don't send so much often data. So we predict the next location, and as you can see on the left side, the location is predicted at the most probable route the vehicle could get. This is not related to an ETA, but it's related under the possibility of the actual vehicle being there on that specially starred location. The second case is when we have vehicles moving in dense urban areas. This is where we have the most problems. So this is the most intensive for us, cleansing and trajectory matching and curating phase of the data, because due to reflections due to the high buildings, we have a lot of errors. In order to correct these errors, we run through the Track and Know platform, and we can see that we have a significant reduction in the cases of either the vehicle is situated over a building or on a side road, which is not part of its actual trajectory. So in this case, we are running also the test case to see how much time we can reduce while we are doing on this online enhancement post delivered from the device to the platform via the Track and Know platform. So this is pretty much how we use in real life a big data platform, and how we intend to, and actually doing it, to reduce times in order to facilitate more vehicles with the same platform, but with better algorithms running on it. So thank you. If you have any questions.
Thank you, Thanasios. So please put the questions in the chat, and we will handle that synchronously.
Maybe just a comment, Arne, because you may remember that before I have mentioned a question from Axel. It was posted in Zoom, so I put it in the chat so that the whole audience benefits from that. And then Richard also made another question precisely to you and to Todor, and I also decided to share it with the audience in case this is useful. So basically, are there also some benchmarks regarding energy consumption or energy efficiency of big data and AI approaches?
Yeah, this was from Wova. This was from the audience already.
Yeah, exactly. No, so
there's also an answer from Brian to hit Axel that you might want to put back in the general.
Yeah, and also we can look at the MLPerf aspect, which have elements on that, but that maybe Reka and Tudor can comment on that. We need to move on for our agenda, so we try to handle this in parallel. Moving now to the DataBio project, which is one of the Lighthouse projects that just finished this year, and the pipeline experiences in Data Bio will be presented by Kai Södergaard from VTT, who is also the technical director of the Data Bio project. So I'll stop sharing and Kai can take over and share and present.
Let's see if I am able to share.
At least we see you, Kai. Just a comment for the next two speakers. We have 15 minutes to finalize this session. So just to be prepared.
Kai, your microphone?
Yes, can you hear me?
Yeah, and
okay.
we can see the presentation. That's perfect.
Very good. And greetings from in Finland. And thank you for giving me the possibility to present this Data Bio, one aspect of the Data Bio project. And I'm going straight to the framework here. So this is now about bioeconomy, and it was a fairly big project that formally has ended, but we are still in a way wrapping up the results and we'll publish it into a book, probably this year, Springer book. And the aim has been here to enhance responsible and sustainable production of food, energy and biomaterials, and utilize the raw material from agriculture, forestry and fishery more efficiently, and of course develop new business opportunity for the more or less the tech providers. And of course, I don't think I have to motivate the importance of this because we are really in the big trends when we are talking about food and energy and biomaterials. And so we had altogether 27 pilots in these three fields: agriculture, forestry, and fishery. And then we then have a common development environment. You can call it a platform that supports all these pilots. And the pipelines, that is now the topic for today very much, are in central for this platform that helps then. Of course, the aim is to help the farmer and the forest owner and the fishermen to make wise and informed decisions in various contexts. And the data are coming from two sources. One is on the left here is from sensors, for example, put into the field that are measuring the soil and the air, temperature, and a lot of parameters. And the second data source is on the right here is space satellite images that almost all of these pilots utilized. And one notation where how we see the pipelines as contrasted to services. So we see that a pipeline, it's in a way, okay, it's this chain of the components that we have seen many times today, but and the components have clear interfaces. But it's a white box in a way that shows the internal wiring for the developer. It's for the developers, not for the end users. The end users should not, of course, be bothered about these pipelines. Whereas a service is really serving the end user and is accessed through APIs and web services and remotely activated and executed in the cloud. That's a black box. And in fact, here we have an example of precision agriculture, where you can see in which shape the crops are on the different fields that are where these pipelines or wiring scheme is generating. I'll come back a bit to this later. And we used, and Arne was very central in this project is sitting on the steering board, and of course, we built on this reference model, and we had about 100, almost 100 technology components, software programs, and so one benchmarking that we did here was to make it was needed, because we had to match these technology components, and came from about 20 of the partners to the different pilot needs that was represented by the other half of the partners, and to be able to bring this matchmaking forward, we modeled all the components, and then we placed them on this. This is now a simplified version of the reference model. But anyhow, you can see that we had components on our layers. Some of them are on several layers, and so this is the number of the components. For example, we have altogether 13 components that we're doing descriptive data analytics. And so these were where we started. Then we selected 62 components from 28 partners to go into the pilot rounds. So we had about.
So Kai, I think you have to speed up a little bit.
Yes, I go. Yes, and here we go. And all together we raised able to raise the technology readiness level about to significantly in the project. And here is another benchmarking as comes to the kind of data that we had here in different colors, and also the domains here. And these are in the middle of where more generic components that could be used in several domains. And so we had altogether 7 generic pipelines. They were used in several. All of these were used in several pilots, and I will. Arne already hinted on these, so I will describe one about IoT data, and that was we have it in our repository, all the descriptions of the pipelines. So here you can see that we go through the stages that had been here, and then we were and this was applied to predict and give real-time alerts of threatening diseases and pest breakouts in crops on the fields. So that's what I shown earlier, and then you can act in time. So that was this one, and you see how the data flows here from the bottom and up and through different stages to finally aid the farmer here in front of his screen, or the advisor to act in time and use pesticides, for example, on his fields. And the second one is linked data integration that has connections to what has been presented before, for example, from Sintef. So the also shown by Arne, this was so it's about integrating data from these different sources that I already mentioned in the beginning. So we have tractors and a lot of systems here, like you can see, and then the data flows through these different stages. And let me say some words about a special feature here is the automatic discovery of links between the data set, the different data sets by using knowledge graphs. So here we developed a new package called GeoL that showed very good benchmarks compared to those that are already on the market, and So here we could combine, for example, identify fields with a specific soil type, or identify all fields in a specific region with the same type of crops like the ones shown, or like here in the picture, you could in a way overlap plots from this LPIS called data set, which shows where the borders of a certain field, and then with buffer zones around water bodies. And then you can see here in orange that this is a risky area. So if you use pesticides on the field here, that can go into the water, and you should act and use maybe less pesticides, or even don't grow anything on that area. So that's a concrete example here, and we have we built then a repository that we call the DataBio Hub, and that is now keeping the assets. It's a catalog and a searchable, and so here we had these 7 generic pipelines, and then 25 instantiations of those, in addition to the software components and data sets and description of pilots, and everything is cross-linked here. So you can go and look at, for example, in which pilots a certain component is used, and so on. So to conclude, so we developed here a common development platform for all these pilots in the 3 diverse sectors. That was not it was a challenging task because they were so diverse, and we used data pipelines, very central here as a tool for the developers, and they were in a way deduced then from a few generic pipelines used in numerous applications, and you can find all those from the DataBio Hub. Here are the links to it, and as I said, we have one book here in just being published for the Spring and Nature, I think this year. Thank you very much.
Thank you very much, Kai, as one of the projects which show the usefulness of the pipelines in different contexts. We're moving now over.
Just for your information, we have like 3 minutes to go, so I think that we will have to hurry up a bit with your.
Yeah, I guess we can take a little bit of the coffee break too. So
yeah, we can do it, but just
because
to be
now we will have Jan Anders Gomez. Maybe I'll skip showing his slides. We already see him here on the screen, so that's good. You can start sharing your screen also, Jan. He is from the University of Politecnica de Valencia, involved in the Deep Health project, which is also one of the Lighthouse projects, showing very interesting work and results related to use of deep learning. And I'll let you talk about it, John, please.
Okay, could you see my screen, I guess?
Yeah.
Yeah.
Okay. Well, good morning, everybody. Thank you for your attention, and I would like to be thankful for with the DataBench team for inviting us to participate in this interesting session. Okay. Well, I'm going to skip slides 2, 3, and 4 due to the time limit. So let me go directly to this one. In this one, in order to contextualize, let us give a definition of a pipeline in our context, focusing on training the models based on machine learning techniques, or in general, artificial intelligence techniques. A pipeline for us is a set of operations sequentially applied to a data block as a set of samples, or we also say a batch of samples. In our case, some operation of the pipeline, in this case, in this example, are executed on the CPU, and the most computational expensive ones are running on an accelerator, a hardware accelerator, which is the graphical processor unit. Well, let us distinguish among different types of pipelines, or different levels of pipelines, better to say different levels of pipelines. In our case, the training pipeline is the most inner pipeline in this representation, then the model pipeline, which includes the training pipeline, and then the data pipeline that encompasses all the stages or all the steps in our pipeline, okay? Well, in this slide, we can see the correspondence between the blocks of the more general pipeline defined in the DataBench project and the stages of our representation of a data pipeline. These two complementary representations will enrich the concept of pipeline each of us have in mind. Well, in any data pipeline, the first step is crucial and it's still necessary to highlight the relevance of this step to avoid that application domain experts start collecting data that will not be useful to reach the objectives of any project or task, okay? Well, here, we would like to catch your attention on three very intertwisted stages at the whole data pipeline, where the data benchmarks should be applied to evaluate data quality and interoperability, among other KPIs and key features of data pipelines, okay? Well, analogously, in this slide, we can see four very intertwisted stages where another type of benchmarks are applied. In this case, to evaluate the performance of the software tools used to train and evaluate models, as well as to evaluate the quality of trained models in terms of accuracy, robustness, the degree of trust that application domain experts have in the models, which is very related to the robustness of the models, and other KPIs. Well, let us show you a real use case as an example of how to design and build a data pipeline in the health sector. Well, these examples allow us to highlight the relevance of the stages more related to data, which are acquisition, curation, and persistency, in order to achieve high quality and interoperable data sets ready to be used by any stakeholder. And also we want to highlight the relevance of the stages related to models where data manipulation are also required. In this case, partitioning or data partitioning and data augmentation. Well, this example of a pipeline is based on the use case number 12 of the Deep Health project that uses the International Skin Imaging Collaboration dataset, plus an extension provided by Unimore that provides more images to this dataset. Well, we have two tasks related to this example, classification and segmentation. For the classification task, we have to train models to distinguish among several classes corresponding to different kinds of spots in the skin. In this case, metadata are labels. Some example of spots are shown in the slide. So each type of spot is assigned to a label or has a label assigned to it. Okay, and for the segmentation task, we have to train model to return bit masks to highlight regions for the limiting spots in the skin. In this case, metadata are bit masks manually generated, which has a high cost in person hours, okay? Well, the training pipeline has been implemented using the libraries ECVL and EDDL created in the Deep Health project. ECVL stands for European Computer Vision Library and EDDL stands for European Distributed Deep Learning Library. Well, as mentioned in the previous slide, this particular use case is a very good example for two different but complementary tasks, segmentation and classification. The output of the classifier provides clinicians with a confidence measure that could be considered as a probability. Confidence measures are used to support doctors during the decision-making process, part of the diagnosis. By the other hand, the output of the semantic segmentation provides clinicians with clues and proofs of what the classifier is taking into account to compute the confidence measure. These clues and proofs are visual representations or visual explanations that contribute to the trust of doctors on the models. Well, after seeing what we understand as a pipeline in our context and an example to catch your attention, let us enumerate and point out needs and requirements to carry out benchmarks at three different levels: datasets, deep learning frameworks, and software platforms. Well, in related to datasets, we think we have to evaluate findability, accessibility, interoperability, reusability, robustness of the anonymization process, and of course, the quality. We leave some questions in the slide that each one of us has to find answers, but there is no time to discuss about these questions. Well, in relation to deep learning libraries and toolkits, we think that at least the following aspects must be evaluated: the speed up of distributed training, that is at the end performance, convergence of distributed learning in comparison with sequential learning, not only the performance, also the ratio of convergence, usability for developers and data scientists, and also integrability into applications and other KPIs that we have no time to focus on now. Last but not least, concerning software applications or platforms the end user has to interact with, the aspects we think must be evaluated are usability, I mean, how friendly is the application, completeness, in the sense that covers all the needs of the experts in the application domain, which are at the end users, and other KPIs related to performance, which are more oriented to data scientists who use the application or platform. Well, this is all from my side, and thank you very much for your attention. It will be a pleasure answering questions, and I think I fit in the time, sorry.
Thank you, Jon. You fit quite well in your time slot, so that's very good. So now we are basically ending this session. I'll just show a very quick summary, and then we'll have a break in a few minutes so you can get a coffee, and then we'll start again. But let me just use the opportunity to just remind you of what we have been looking at here. So the last session too, I looked into 5 different projects, and basically all of the projects have related to the reference pipeline, as you have seen, and there are 5 presentations all relating to that. So starting with IBDAS, going on with Day-by-For-You and the 2 benchmark areas there, going then further on to the Track and Know project that showed how the architecture relates to the pipeline, and further to the DataBio project that has a number of implementations of all these pipelines, and then finally Deep Health, which have an interesting detailing of the machine learning pipeline, including training and validation and testing. And again, all of the benchmarks we saw in the first session are related to these steps and has a number of benchmarks that can be applied in this context. So our schedule is basically a short opportunity to get a coffee in a few minutes before we go into the business framework perspective of this. And then I think, Nuria, you might say a little bit about what happens next.
Yeah, so basically in the second part of our workshop today, you will get some insights about the business framework generated by DataBench. We have seen from the projects that basically they are interested in both technical benchmarks, but also business benchmarks. And we will show the way we are putting things together. And finally, we will go to a demo session where you will get some insights on how to use the toolbox that we have created. Finally, we want to know the way we are making all these concepts somehow practical to the company so that they can really benchmark in an easy way. That was the intention of the project, lowering the barriers to do benchmarks. So basically you will see what we have created in the toolbox and the way you can use it depending on your profile. So I think it's a very interesting part. We will have 2 sessions of half an hour each, so it will be shorter. And I will also repeat you a bit the practical aspects of the session afterwards when we come back from the break. One thing, Arne, I think is that it would be very good to invite other projects that may be attendees today to the session, or companies that are interested in benchmarks to come with us and to contact us, because we are running a validation process now. So you have seen some of the projects and the way their pipelines map to the pipelines we have defined in DataBench. We would really like to count on other projects and other companies interested in the topic to help us improve the toolbox. So this is an invitation basically to all of us to contact us if they really want to participate in the process.
Yeah, and we also would like running projects and other activities to categorize their activities in the 4 steps of the pipeline, because this makes it much easier to compare and understand reusable results coming out of various projects. So hopefully we will start up activities in that area too.
Yeah, so thank you very much, Arne. I think we leave now a bit of time to people so that you can grab a quick coffee, as we say in the slides. So we reconvene again at 12:30 and we will start with the business session. I hope you enjoy so far, and I hope you will be back in a few minutes to go on with us and to have an interesting time together. Thanks a lot.
Thank you. Thanks. Bye-bye.
Thank you, Nuria. Thank you, everyone.
I think you can put yourself in muted, and you can keep the session open.
Hello, Nuria.
Hi. Shall we start again, Richard, or we wait a couple of minutes more? I'm not sure if people had enough time to go to the toilet and grab the coffee.
Okay, I think we start and then people come back when they want to. Otherwise, we'll go a little bit long, right?
Do we have Gabriela connected?
Gabriela's here.
Okay, that's perfect.
So,
Okay.
Gabriela,
Very good, Gabriela.
Pierluigi, Harold, and Chiara, if you can turn on your microphone and your camera only when you're speaking.
Okay, sure.
Yeah.
Okay.
So again, as I mentioned to the colleagues, basically now we are going to the second part of our workshop. It will focus on Big Data Business Framework and then the tooling support that has been generated by the DataBench project. We will start basically with the framework, and this will be led by my colleagues Gabriela Cattaneo from IDC working in the DataBench project, Chiara Francalani, professor at the Politecnico di Milano, and Enrica Spinoni also working for IDC. And then, as I also introduced in the very beginning, we will have two external speakers of companies we have been working with, who are Pierluigi Petrali from Whirlpool and Harald from Phil. And just before I give the word to Gabriela, who will be moderating this session, I would like to remind you again that there are basically two functionalities you can use in the WOBA platform. One of them is for questions and answers. You can post your question there, and like this, we will control if the questions are answered. And then you can also post your comments in the chat window. In any case, I'm checking both of them. So if you post a question in the chat, we will also go through them. Maybe also instructions for our panelists, because you saw before that most of the panelists share the questions and the comments in the chat of the Zoom, and then we had to copy and paste them in the WOBA platform. So I think it's important that all of you interact with WOBA, because basically this is the place where it will be shared with the community. If you don't do it, I will do it as I did in the previous case, but just for you to know that if you do it in Zoom, I'm not sure if all people can see it, and for sure it will not be recorded. For the others, it will stay. If you post your comments in WOBA, basically they will stay for the community also after the session. So I think this is quite important. Again, I encourage people to participate, to post their comments, and to help us to improve. And without further delay, I give the word now to Gabriela Cattaneo, who will lead this third session, which is very interesting, by the way. Thanks a lot, Gabriela.
Thank you, Nuria, and I'm happy to be here. I'm sure I'm going to share my screen so I can show you the presentation. Can you see it?
Not yet.
Not yet.
We see you.
We see you.
And now it's coming. Perfect.
There's your presentation.
Perfect.
You go to presentation mode.
Okay, let me just put it in presentation mode. There you go. Okay, so thank you to everybody who is here to listen from our experience in the DataBench project, which had this goal to fill the gap between technical and business benchmarking in order to help stakeholders to make better decisions based on data on their technology, big data investments. In this session, which is going to be quite, sorry, I was still, there you go. In this session, which is going to be half an hour, so we'll be running through some of our results, but you will be able to see all of them and access our results and our data from the DataBench toolbox, which will be demonstrated right after this session. In this session, we will focus on benchmarking big data. So first of all, I will say a few words about the business impact of big data and our KPIs, how we developed them and how we validated them as benchmarks. Erica will give you a quick view of the values of these benchmarks and what are the type of benefits in terms of profits and revenues that we can hope and expect when making these investments. And Chiara Francalani, who's led the case studies activity and much more in this project, will say a few words of our considerations based on the in-depth analysis of experiences. And then, of course, we will hear from Pierluigi Petrali and Harald Serschon about two pilot experiences with big data and the way they have been measuring their business impacts. So please ask questions as much as you want. Just a few words about how we, our technical approach, our conceptual approach to match technical and business benchmarking. I'm not going to go into detail, but in this conceptual framework, you see that we started from the industry needs, from the different European industrial users' needs. And then we looked on one hand on the way big data is processed and used in the companies. And this is what you discussed this morning, by the way, modeling the various data pipes, pipeline, and modeling how technical benchmarking could be used. And on the other hand, we have investigated the main big data technology business impacts based on 8 KPIs that I will show to you in a moment. The key point here is the concept of use cases. What we have investigated is how when companies make an investment decision, they focus on use cases which are business processes for specific applications, such as predictive manufacturing or predictive maintenance in manufacturing, or predicting customer churn or others. And through the use case where we apply both a technical solution and we look for business impact, we can understand how we can combine technical and business benchmarking. The KPIs that we developed are the following that you see here. We have 3 KPIs which have been measured as actual increase, revenue, profit, and cost reduction. They have been measured as a percentage of increase for each organization thanks to the investment in big data technologies. And then we have other KPIs which have been measured through ratings in terms of the range of improvement. So there are classes of improvement from less than 5% to over 5% to over 10% and so on. And they are time efficiency, which is a proxy for productivity, of course, the improvement of product and service quality, customer satisfaction, new products and services launched, and business model innovation. We have measured these KPIs for all industries and all company size classes, and you can find them in the DataBench toolbox. You can find the data of the actual KPIs in the knowledge nuggets part of the toolbox, and you can see this in the next session. Why these KPIs can be used as industry benchmarks? This is an important difference because it's quite frequent to see, for example, business surveys in which you measure an average improvement of, I don't know, average benefits from a technology, and this is not necessarily a benchmark. In our case, we say these are benchmarks, that is, they represent the median value of improvement for representative parts of the European industry, because they respond to the actual and emerging needs of specific industries and specific company size segments, because they are measured for all the relevant European industries and company size segments in which big data can have the highest impact, and because they are measured for the main use cases, and so they are useful for linking technical and business performance, and they have been validated through case studies. We have a sound base of evidence about industrial users' needs that we have used in the DataBench project. Data collection was based on a survey with European organizations from the 9 main industries and 5 company size classes, resulting in 700 interviews. We carried out a complementary survey of big data business pilots in Horizon 2020 ICT projects, which resulted in another 30 interviews. And we have 22 in-depth case studies. We have been mapping 35 big data and analytics use cases, which have been selected thanks to IDC research on what are the top use cases for these technologies. So this is a sound base of evidence. And this tells you why we think these benchmarks are relevant, and you can use them if you are a user or a technical developer. You can look at our benchmarks and see what are the performance that you can expect by industry and company size. And this is a very important result. We can also say that in our research, benchmarking the business impacts of big data technologies was declared as relevant by 90% of our respondents of European enterprises. So this is a very important aspect, and we'll investigate also why in the next part of the session. Now I want to give the floor to Erika about what are the actual results of our big data benchmarks. Erika?
Thanks, Gabriella. I hope you can hear me fine. So I want to start to have a look with the final benchmark for the main industries analyzed at the DataBench project. And first of all, we can see there is a group of leading sectors who have achieved a median value around 6% of profit increase and 5% of revenue increase, thanks to big data projects. And this came not as a surprise, as we know that financial and business IT services sector are leader in the use of big data, as well as in telecom and media and utilities sector. However, what is particularly interesting is that the values for cost reduction looks lower compared with profit and revenues increase. And this is because companies are more focused on competing on revenues increase and improvement on services rather than simply cutting costs, even if this is still a big element in competition. But looking at less advanced industries in big data adoption, namely agriculture and healthcare, even if they show a healthy improvement of profits and revenues, they're actually less advanced than others in terms of achieving benefits, especially for qualitative KPIs. And this reflects the slower technology uptake. Then moving forward, manufacturing is very interesting, not that moving forward, Gabriella, just...
Oh, sorry.
Okay, thank you. Moving to the manufacturing sector is a very interesting case because it's the biggest and most diversified European sector. And what is really appealing in manufacturing is that despite median values are in line with the European average, the use case analysis, we find a wide range of benefits, particularly higher than the median. And this is particular for new product development and supply chain optimization. And now moving to the analysis of innovation benchmark, we know that the majority of companies have achieved benchmark around 10 to 24% improvement. What is interesting is that the analysis of manufacturing sector, again, in which business model innovation is the area with less improvement. And this is because of change of revenue model, maybe is not the most important factor, but because the focus is more on product quality and customer satisfaction. However, as we can see, compared with business IT services and utilities, manufacturing still rates with less relevance, customer satisfaction and product service quality compared with the other two industries displayed. In these latter two cases, it is clear that the attention given to customer-centric and external-facing KPIs is a sign of strong relevance of pure innovation-led business KPIs. And then shifting to the analysis to the company side, thank you, Gabriella, it's clear that and striking the progression in the value of benchmark from small, medium enterprises up to very large ones, who shows the highest impact thanks to the economies of scale and ability to leverage large data sets. The combination of leading industries in big data technology uptake and company size is confirmed as the main explanatory factor for high KPI benchmark values. The quantitative KPIs for small, medium enterprises and mid-sized organizations have not large differences on how big data technologies are impacting on profit, revenues, and costs. And the benchmark values are close to this overall sample results. While for large enterprises, so moving to the next size band, are strong adopter of big data technologies and represent a large share of the survey respondents for us in our DataBench survey. Their KPI benchmark, however, are not that different from the previous size segment with slightly better revenue increase impacts. And then last but not least, very large enterprises claim the highest KPI benchmarks, particularly in the case of profit increase. As we can see, it's a +6%. These enterprises were among the first to adopt big data technologies, and they have been able to reap the main benefits, thanks partly thanks also to availability of data sets in-house. And then something more about our study, because we have also broken the survey data to better understand which are the best practices and who are the best in adopting big data technology, regardless the company size, the industry of adherence. But for more information about this, that we call star performers, please have a look at the deliverable 2.4, benchmark of European industrial significance. And now I'd like to leave the floor to Professor Chiara Francalanci from Politecnico di Milano to study and review the case studies results. Thank you.
Thank you very much, Erika. Okay, so to get some further understanding of the results from the extensive survey conducted by IDC and provide some additional insights on the business impact of BDA and the benefits from technical benchmarking, we have conducted a case study analysis. We have analyzed 22 case studies across 8 industries. We have worked with these companies at different levels. With some of these companies, we conducted a survey with all of them, an in-depth survey, with all of these companies, and with some of them we have been able to actually get their data, work on their data, participate in some of their BDA implementation initiatives. We have collected a good cross-section of use cases from different industries at a good level, and we got a good level of understanding on the progress that these companies have made. Okay, next slide, Gabriella, please. Thank you. So these are just some of the insights that we have obtained from our case study analysis. Well, first of all, we have found that the business KPIs are the evidence from case studies is totally aligned with the evidence from the survey in terms of business KPIs, and business impact is in the 4 to 8% range, depending on the industry and on the specific use case. And companies in the case studies have measured business impact mostly in terms of profit and revenue improvement. All of them agree on the idea that business intelligence has been deeply changed by BDA, by BDTs, big data technologies, and particularly the challenge now is to delegate decision-making to machines. And this raises a whole range of new challenges. Companies are well aware of the opportunities, but on the other hand, they think that for machines to be able to make decisions, they have to start from collecting the data and making them available in real time. Many of them are concerned with data quality and data governance issues. Due to this initial effort, only a few projects have actually already reached the deployment stage. They haven't lost momentum, but the implementation is, quite, long and challenging, as it involves a deep organizational change. Regarding the role played by technical benchmarking, all companies have agreed that making the right technical choices is actually key, especially to support long-term change as, data volumes increase and projects reach full rollout. And they all agree on the fact that IT benchmarking is critically important. On the other hand, they also point to the complexity of technical benchmarking. And well, in this respect, the efforts made in DataBench with the implementation of the toolbox to make benchmarking, IT benchmarking simpler and to provide a one-stop shopping for IT benchmarking needs for companies is actually considered very useful. Okay, so now I leave the floor to the next two speakers from the industries, to companies that have actually participated in our case study analysis and can provide more insights.
Thank you, Chiara. So we rushed through our main results just to give you participants an idea and the frame in which we have been working. I want to point out, however, that we have also produced a handbook, a DataBench handbook, which is planned to support the DataBench toolbox and provides the background and the evidence of what we have been discussing so far, as well as the technical benchmarks. So you can find more about the research and how to use it in this handbook, which will be published soon. I want to thank Pierluigi Petrali, Operation Excellence Manager of Manufacturing R&D from Whirlpool EMEA, the main wire appliances manufacturer. And I want to introduce, hello Pierluigi. So I want to ask him, thank you for joining us, first of all. And I want to ask you a couple of questions. And I think the first one is about, can you share with us your experience with the pilot you ran about spare parts maintenance, I think it was, and how it was, you looked at measuring the impacts and the benefits that you got from using big data technologies. Please.
Of course. As you mentioned, our use case was based on the improvement of a forecasting for the management of spare parts. Spare parts are quite an important part of a consumer service department, because of course you can imagine white good appliances has to keep all the parts that can be used for repairing your appliance for up to 13 years. So you can imagine with all the models, all the different brands we have, it's very easy for us to have all the warehouses in all Europe full of material that maybe can be used just once a year. So our idea was to improve the system that we had already. So it was mainly a forecast based only on historical data, and to integrate this system with a new approach that were taking into account many other different sources of data. So not only look at the past spare parts data, but also involving production data, quality data, and so on. So we were perfectly in the shape of a very high variety, just taking into account a couple of V of the famous 5V or 7V of big data. And so the experiment was, of course, conducted along the Boost 4.0. So we had a strong partnership with the Tecnico Milano, with the SAS Institute that helped us a lot in defining the new system. If you can move to the next slide, we can focus immediately on the results. First of all, I want to add these things. We decided to group the KPIs into three main families. We call them operational, tactical, and strategical. And of course, operational are those that are telling us that the system is working properly, so that the algorithm, the software, the application is doing what we asked it here to do. The tactical is already an application how the algorithm can provide in terms of initial business results, which are not yet turned into revenues of cost saving. That's what is happening in the strategical field. Of course, this is also a time bound. So first you are reaching operational, then if you are able to transform those operational into something that can influence direct your business process, you get into tactical. And if you can keep those activities well maintained and integrated into your overall business process, you can achieve all strategical objectives. Of course, the process is not yet finished. It will end December this year. And so far we can have evidence only for operational and technical evidence, KPIs. On operational, we were very, very satisfied. We were able to improve our capability to make forecast that has been measured by the total error between the actual data and the forecasted one by, you can see probably here, The previous forecast is the orange one. The new forecast is the green one, and the actual values are the blue one. So the green line that you can see here in the small picture is actually very close to the real one. And also, we were very happy because the system was well accepted by the operator. So they were really appreciate the system to interact with it and to use the new system. Of course, we had the time and the opportunity to transfer those results into some specific operation. And so we have some tactical results. So we managed to reduce the spare part, the stock value. You can see here the value which is decreasing a lot, and also the plant service level. So the ability of the plant to provide the right components at the right time to the service. As said, we are very satisfied. Of course, we learned a lot. We learned that using big data, we can really improve things. And that, of course, it's not just a matter of machine and data. It's also a matter of the experts putting their experience, their knowledge, their attitude. That sometimes is also to change a little bit.
Can I ask you then how important was to measure the impacts and the results of this pilot, and can this is this a condition to scale up this experience and really scale up also the benefits? What do you think? Being able to measure the benefits and the results.
Any other project you can
Sorry? We lost you, Gigi, I think.
Yeah, I think it seems like if the image was stopped.
Frozen.
Sorry, I can't understand what you said because I have some disturbance on the line.
Okay, I asked you if how important you think it's to be able to measure the impacts, so benchmark the results of this kind of pilot innovation projects, and how is important in order to scale up the results to the company and to the processes. We lost him again. Hello?
Gabriella, I think you're going to have to just go forward.
Yeah. Okay, I'm sorry, but Gigi, thank you very much. I think it was very interesting and we see concrete benefits. Time is really hard. So Harald Zerschön, are you there? Can you, I'm sorry, but I see only my slides. I don't see your picture. So.
Yeah, so now we see Harald's presentation. You're good to go.
Yeah, good. Harald, can you tell us your pilot study and the results you got from it?
Yes, hello, and thanks for inviting us to give us the possibility to give you insights on the Boost project for the Big Data initiative for industry. And Gabriella, you have another slide ready to...
There you go. Shall we try to launch the video?
No, I will do it from I will overtake in a second. So just to give you the possibility afterwards also to look up this film. It will be uploaded and replaced with the newest version. So the Boost, as already discussed, was giving us the opportunity to check the big data approach for the industry. And as you can see here, we followed business objectives with reduction of service costs and with reducing the unplanned downtimes and reducing the commissioning time and the long-term reduction of machine developments. This is the KPIs I want to present. So I will give you the film.
I need to stop sharing.
So,
there you go.
So everybody is seeing now the information gap?
Yes, we see.
Okay. So
we see it.
Yeah, okay. So I will start the film, and the good for you is it will only last 2 minutes, and I have to hurry up following the film explaining. So the information gap is when we bring machines to our customer. So we are selling machines. After having brought them there is a break in the information on the big data approach. So mostly information is done manually. And this was the Boost project to fix this issue. So we followed the methodology for mechatronic systems, where you have fulfilling the customer's requirements for the system integration. And there in the business process, we wanted to reduce the engineering lead time by introducing models for testing, improvement, validation, and put them in the repository. And in fact, we could estimate that 15% were foreseen before, and we reached a huge impact with more than 25%. The second KPI was the unplanned downtimes. There, we introduced the big data harvesting process, and with preparation and exploration of those, feeding the engineering process in the model integration, we could deploy these models and support the engineering process. And here also, we reached the target we foresee for the Boost project. The third one, the service development process, could start very early in this design process with the engineering. And so we could reduce the service costs also, as we estimated, with 15 and overrun it by 19%. And the last I want to present is the simulation-based release process, because based on this big data, we have the possibility to build up product service systems on which we can reduce the bring to service time, the commissioning time, and this was also overrun. So this is a very short and brief description of the Boost project and the KPIs we took for measured impact. And it should show you that as we use the DataBench, that we are within this group shown by, I think was Chiara, no, Erika, where this manufacturing industry is within this range of 10 to 25% increasing their performance. So that's it. I'm ready for your questions.
Thank you. I don't know if we have time to ask questions because time has run very fast. Can we ask one more question to Harald?
People can use the chat box as well in the Wova platform to ask questions and answers. And this way we can also answer them in line while the presentations are going. So go to the Wova platform in Q&A and ask directly your questions there.
Yeah, I'm checking the website, but I don't see, I saw that there are 5 questions now in the questions and answers part, but I don't see any new one with respect to the ones that I mentioned before. If I'm wrong, please let me.
I think I want to ask again to Harald the question I wanted to ask before, that is how useful is measuring the impact in order to scale up this kind of pilot experiences? So how important is benchmarking to help companies scale up their innovative investments?
Oh, it is very important. There are 2 options. One is we want to be the benchmark. So I want to see in the industry group with competitors or comparable manufacturers, where is my performance and how do they measure their success or their performance. And the second is doing this impact measurement over time. So this is now measured before Boost and at the moment with certain projects we took for building up the KPIs. And I have the possibility for now on to measure this that I can keep with this performance. It will not increase until, I don't know, double every year, but we want to keep this level and slightly increase it.
Thank you very much. I think this is a very good conclusion for our session, Nuria. And I think we are ready to go on to the toolbox demonstration. I want to thank you again, Harald and Gigi, for sharing this session with us, and Eric and Chiara for explaining our approach. Thank you, and I'm giving over.
Maybe,
yes?
Gabriela, just one last sentence is you mentioned this customer satisfaction KPI.
Yes.
And this is also within our vision or philosophy, so that we have customized solutions, and customer satisfaction is very important. So I think for the future, I'm very interested also in the DataBench project to get insights from you, how others are measuring this customer satisfaction. So which factor is it? What do you fill in there? Would be interesting for us.
Sure.
Thank you.
I think this was a very interesting session, Gabriela. Thanks to all the speakers, especially also to our colleagues from Whirlpool and Phil to participate in the session because we appreciate very much your collaboration. Because of time is running, let's go directly to the last session of today's workshop, which is a practical journey on how to use the DataBench toolbox. So far, we've seen a lot of concepts, a lot of frameworks, theoretical things, but how do you put all this together and how do you make it useful so that companies can really run those benchmarks and use them for their decisions? I think, Thomas, you have a hard time today because you will have to convince the audience on what we have done in DataBench, what is the real toolbox, how it can be used, and what kind of benefits it can provide to projects and to companies interested in the topic. For some reason, Richard stopped my video. I cannot share it anymore, so it's not that I'm unpolite, but and then Thomas, I think the floor is yours. I think that we will also have an interesting session with several speakers, so tell us a bit about what we will get now.
Thank you, Nuria. Thank you very much. Yeah, I hope you can see my screen right now. But the idea in this session is to go through this toolbox, but not only the toolbox, but we will have interesting talks as well. As you will see, we have 3 speakers, myself, the first presentation about the toolbox with a brief demo. Also, we have Marco Grobelnik from Joseph Stefan Institute, who will give us an overview also of a tool that is included in the toolbox, which is the AI Observatory. And we have also Daniel Saed from ITI, who will give us a perspective on the use of benchmarking from Digital Innovation Hub's perspective. That I think it will be a nice ending to this session and to the whole session, I would say, of DataBench in this event. So as time is pressuring us, let me go directly to the demo, the DataBench toolbox. I hope I can live to the expectations raised by you, Nuria, and by all the previous speakers, because you were all referring to the toolbox. The toolbox itself is a tool that we would like to share with the audience, that is intending to be a kind of one-stop shop for big data and AI benchmarking, showing results from the project, but also results from existing communities, other tools that are available for benchmarking. So being in a way a place to go and search for your specific benchmarking needs in case you have any doubts. Of course, if you are an expert on benchmarking, probably you can skip this. But nevertheless, we are providing not only access to a specific technical benchmark, but also, as Gabriela was commenting, we are giving the possibility of accessing to many other things related to business benchmarking. As you can see here, we have access to pipelines and blueprints, to results from use cases as the ones that Chiara was mentioning before. We will publish here also the handbook, which is in production right now. We have this concept of knowledge nuggets, which in reality is pieces of knowledge that has been taken from different places and are available through the toolbox. We have the catalog of benchmarking tools, which is, let's say, the core of the toolbox. But also we have some hints about methodological aspects on how to deal with benchmarking. Last but not least, this AI bench observatory that Marco is going to present afterwards. So very briefly, just to mention that in the toolbox we have different users in mind when we thought about the toolbox. On the one hand, we have the benchmarking providers, which are the people or the communities that are actually providing these benchmarking tools. We have the PPP projects, researchers in general, that are interested in these benchmarking initiatives for their own purposes, and also to align with existing initiatives such as the BDBA, the DB reference model, or the blueprints that Arne and Todor were presenting before. We have more technical users that actually they would like to benchmark their solutions or benchmark something in order to decide which is the best tool to use. And for them, we have this catalog, all the searches that I'm going to explain very quickly. And last but not least, we have the business users that are more interested probably in this knowledge around a business KPI that both Chiara and Gabriela were commenting before. So we try to operationalize, however it's said, this work done in DataBench in different aspects, and I'm going to the toolbox now to show you in a brief demo how to do so. So let me switch to the browser. 1 second. If I can find my browser, by the way. Here it is. So this is the front page of the toolbox. So as you can see here, the front page is a kind of a typical web page where we can find several menu items. Right now, I'm logged in as an administrator, so I have more options available than a regular user that is not logged in. So you can log in, you can enter to the toolbox without a user, but you will see less functionality. So we encourage people to actually register, which is free, no problem, and you will see more functionalities. Not as much as I do because I'm an administrator, but many of them. So for instance, when dealing with benchmarks, we have the possibility of I have as a provider, because I have the possibility of creating new benchmark into the tool, or browsing the catalog, which is an open option for everybody. But I can also update benchmark, or even see the results of some of the benchmark that I executed from the toolbox. Same happened with knowledge nuggets. Normally, people with not registered, they have the possibility of just browsing the catalog. Or I, as administrator, I have the possibility of seeing some metrics of quality of the site, plus connection to other tools such as the AI Bench Observatory that we will see later, and also some specific searches that we have here. So the most important thing in this front page are the user journeys. So what are the user journeys? Is there a way of understanding how users, different type of users, could face the toolbox and try to find what they are looking for, basically. So we divided these user journeys for the 3 different type of users: technical, business, benchmark providers. And for them, we provide some hints in order to make the most useful journey for them into the toolbox. So you can always look at, for instance, at the list of benchmarks, browsing the benchmark catalog. So you will see here, when browsing the catalog, that we have many benchmarks here. The ones that Arne was mentioning before, all the list of more than 50 benchmarks here. And you can even filter this benchmark. We have a filtering where you can, this is a full text filter, where you can type anything like, I don't know, AI or ML, whatever, and you will filter the ones that are related to this particular subject. But if you would like to go directly to the user journeys, if you are, for instance, a business beginner, and you click on the business user journey, you have the possibility of having some specific hints for you about how to use the platform in a better way. So you have links to the frequently asked questions part. You can also have some knowledge nuggets, these pieces of knowledge that I was talking about before, for beginners that are important for you to understand exactly how this could help you. You can have direct links to many things, such as the guided search. I'm going to that later. But if you are a bit more advanced and you would like to understand other things, we have some recommendations, such as using the self-assessment tool. Also, we have some specific searches that you can click from here, or you can actually include in the search box, because there is a possibility of searching in the whole DataBench toolbox. But you can, for instance, look at the clicking here, you can see the different nuggets related to KPIs. And in here, you can see, for instance, that some of the information shown before by Gabriela is actually available from here. For instance, those are the business KPIs that she was showing. Also, you have links to the specific deliverables where this is explained, or even you can download this as a PDF. So there's a possibility of accessing to all this information. And of course, you can even here, I don't know if you are interested, for instance, in a specific sector for these particular nuggets that were here. So you can see that just typing here, you can actually go through to the specific sector and check the business aspect that also before were shown by my colleagues. So this is an example of how you can use very easily from here some of the aspects related to the business, but also we have some more advanced user journeys where you can click and suggested for you, such as, for instance, the way of accessing to the results on this desk analysis that Chiara was mentioning before, and how this is related to the business KPI. So you can read through this. You can then understand how to make use of these results. But you have also links to many aspects. So, for instance, you can check the information about quantitative KPIs for industry, and you get different information that was mentioned before, I think, by Erika, or you have different graphs for quantitative KPIs for company size, etc., etc. So you have a structure in the user journey, a way to access to different type of information. So this is important for you to understand that user journeys will be also updated regularly. So we will include more user journeys or fine-tune these user journeys based on the feedback that we got from you. But the idea is that you have the possibility of doing so. But now, taking also advantage of one comment that we had, one question that we had before, you remember that someone posted a question related to the energy consumption, how they can find the benchmarks related to energy consumption. So there is a way here, there is a search, we have different type of search, but this is the guided search, where we have all the features that we are tagging, with which we are tagging the different benchmark and knowledge nuggets, where you can actually search by specific features. And in here, you see that there are many features. Those are tags that can lead you to benchmark and nuggets and information that is related to that specific part. So in the platform level performance, we have, for instance, I don't know, you can see well, but we have the tag about energy consumption. So by clicking here, we have the list of benchmarks that are related to energy consumption. So you can, by selecting in the guided search the right feature, the right tag, you can actually navigate to each of these. And by clicking on one of the benchmarks, you get the information about the benchmarks with links to the specific web references, with more information about the workloads, the data types, technology stack, metrics that they are using. And in here, you can see probably that energy consumption, for instance, is part of the metrics that they are measuring. You have also links to some reference papers, etc., etc. So from here, you have also all the tags, and you can navigate from one to another. So you are diving here, you would like, for instance, to go to some specific benchmark or knowledge about media, images, or videos. You have the possibility of looking at the different benchmarks or related nuggets that deal with video or with images. So there's this navigational aspect of the toolbox that you can always use. So I don't want to take a lot of time, because Marco also how you can use different type of searches, because we were talking about the BDB reference model. And all this taking time, probably because of my video. This search is about having the possibility of searching by specific areas of the BDB reference model. So you click in any of the verticals or horizontals, for instance, let me click in data analytics. You can see that you can also go to the benchmark that are related to data analytics here, or to the knowledge that are related to data analytics. That will be there are many, but everything is here ready for you to get. And you can click in any of the aspects of this vertical or horizontal, and you will be directed to this particular benchmarks. But you have also another search that is quite interesting, which is the search by blueprint that was also mentioned before. So in this search is related to the blueprints that were explained, and you can also search for different aspects of the blueprint. So you can click in each of the BT block, each of the steps of the blueprint, and you can get, for instance, if you go to data visualization, you can get all the results for data visualization related to benchmarks or to knowledge nuggets. But also you can click on a specific part of the generic blueprint. This is the generic blueprint that was also presented before. So for instance, if you click here, which is the public subscription broker, you will be directed to the benchmarks that are somehow using or dealing with public subscription message brokers. So you have here some of them, and you can even have some extra information about what this is about. When you click on this information, you also have all the list of technologies that with links where you can go, for instance, to this Redis public subscription message broker and get to the page where this information is getting. So in a sense, as you can see, the toolbox is a framework where you can get information not only from technical benchmark, but also from business perspective, giving access to all the information provided by the project, but also for external communities. And the idea is that this is going to grow in time. So we are continuously updating this information. So it's not something that is written into stone. And we, of course, will welcome any additions to the toolbox, especially as Nuria commented before. We are running a validation in a couple of weeks' time, or 3 weeks' time. And the idea in this validation, one of the ideas is to actually get blueprints from the different projects and maps to the BDB reference architecture and to these pipelines that were mentioned before. So you are welcome if you would like to participate, and please contact us in order to do that. So let me go then, just to finish my presentation. Let me just.
Thomas, in fact, we have like 5 minutes for the whole of it. We will go a bit beyond that, but we really need to hurry up.
Yeah, I finished my presentation. I just want to go to present the next speaker, which is Marco Grobetnik, which is going to present the AI Bench Observatory. Marco is from the Joseph Stefan Institute. And well, as you can see in his CV, he's a representative from Slovenia in many committees related to artificial intelligence, and also is in the UNESCO International Research Center for AI. So Marco, the floor is yours. I will stop sharing 1 second.
Yeah, thanks.
If I can.
There's this button. There's this button.
Yeah, but I don't know why the Zoom is not showing in my screen right now.
We see the slides, but we don't see them in presentation mode.
I have a little bit updated slides, and I have live demo, so I would prefer to have my own screen.
Yeah, that is because I don't know why the controls are not showing. So it's strange.
Close all the windows.
So you need to stop sharing, Thomas?
Yeah, but the Zoom is not showing in my screen. It's like it's freeze.
You have, I think that you have to go to the upside of the screen, and then it will come, and you will see it.
Yeah. Just in the downside, down to this.
No, I know, but it's not working. It's not responding. Probably.
Okay, so I can, if Marco just presents now, takes the presentation, stop Thomas's presentation.
I don't know if Marco can do it, but maybe Richard, you can do it.
I think I can do it. Seems like.
Okay, perfect.
Seems like that.
Let's try.
Okay, I will reconnect to.
Perfect. Now I think that
yeah, there you go. Go into presentation mode anyway.
Yeah. Just give me a few seconds.
So Marco, you have changed the background from EVDVF to the sea.
Yeah. This is actually this is Monterrey. Monterrey. Yeah. Okay. So I'll be fast. Let me just.
So hit presentation mode down on the bottom right.
Yeah. Okay. Okay. So my topic is to present as part of the DataBench toolbox subcomponent, which is about tracking the field of AI and big data across several dimensions. Well, because DataBench domain is kind of used already, so we call this now AI Bench. And as said, so this is an online tool to observe the evolution of the AI field and big data across on a monthly basis, roughly, although some parts can be observed even faster across several dimensions. And as a result, we have this DataBench popularity index, which sort of ranks AI and big data, right? Either system technologies, everything what's kind of relevant. What we have, how we observe the field of AI, right? And big data in this case. So these are the data sets we have. So one is Microsoft Academic Graph, where basically we can observe research, global research as it happens. Roughly, we have 1 million new publications per month. So we can see what's being researched and what also all the patents, pretty much what technologies are being patented. Then we have full coverage of global media. So this is coming from the system, our system event registry. So basically we can ask what of these AI and big data technologies are covered in media worldwide, right? Then we have full access to GitHub projects. So we see what GitHub projects are being active at the given moment and what technologies are being used there, right? So if we isolate AI by itself, right, we can see what AI technologies are being used in this currently active GitHub projects. Then we have database of Horizon 2020 projects, so we can see what's being financed by EU. This is always interesting, right? And what appears in terms of technologies in the Horizon projects. Then we have real-time stream of job postings. So we get basically a few 100,000 job AI and big data related job postings per week. So in that sense, we see what kind of skills and tools are required currently on the job market. So basically where companies are investing for their future. We have access to Google Trends API, so we can see what people actually search on Google, so what's popular. And as the last thing, we have also more or less real-time databases of investments, so we can see where the investors are putting their money. So this is roughly, so the last bit is not included yet in the observatory, the rest is working. So this is roughly how we can observe the ecosystem, right? Mostly this would be like on a more like monthly databases, a monthly basis, although some of the streams are even faster. Let's say weekly trend would be also possible. Yeah? Okay, just maybe briefly one slide. So here, as you saw on the previous slide, we deal with fairly heterogeneous databases, right? And data streams. So we need to align them somehow. So what kind of vocabulary are we tracking? So we have taxonomy of AI and big data related terms. So this includes technologies, algorithms, and more aggregated areas, right? So basically we took taxonomy of science, AI part of taxonomy of science from Microsoft academic graph, and database terms and concepts collected from DataBench. So altogether, it's roughly 1,700 tools and technologies in the fields of AI, big data, and benchmarking. So all this is put in one schema, which we track in kind of this business real time, right? So here below, it's a simple example how one term like Apache OpenNLP, right, is then mapped to different schemas, which are then tracked across this data. Okay. I have now briefly one live demo how this actually works. So the system is accessible at aibench.ijssi. Hopefully you see the numbers on the screen. Okay, here you see on the top, you see like 6 tabs, right? Six pages, and we'll briefly go through some of them. So on the first page, we can see across the 6 dimensions. So the financing is at the moment not there yet. We can see the areas. Maybe this one is a little bit more popular. So tools from the area of AI and big data ranked. So if we check here, we see what kind of tools appear in academic papers, right? And also in time. What appear in your projects. So we get slightly different pictures, like, I don't know, autonomy, Google R, and so on, right? So this is for the whole period, right? What tools appear in media news? What appears on GitHub? We would get Python, obviously, TensorFlow, these are most popular ones. What appears in jobs, right? Job market is slightly different as compared to academia, right? So SQL Server, MySQL, VMware, these kind of tools, and of course, well-known ones. You see that the list is fairly long, right? Search volume is what appears on Google Trends, what actually people are looking for. It doesn't need to really fit the job market or GitHub projects, right? And here we have a composite index for all of them, right? So this is one possible view. So another possible view is this more like 5-dimensional visualization, where we can select X and Y. So in this case, you see these bubbles are moving in time. So here behind you have time. More to the right, more academic production is on that particular term, right? Higher means more often that particular term appears on in the job postings, right? So here we see that, so ideally a technology would want to be on the upper right corner. This means it's well published in academia and also required by job market, right? So this is like an ideal technology, right? Yeah, we can see this, how this evolves through time. At the moment, we have data from 2017. Most likely will stay there because it's a little bit harder. For some data sets, it's harder to get information. But we can parameter, change these dimensions and so on. It's fairly flexible graph. Another,
you have to hurry up because we are running out of time.
Okay, I'll be very fast. Okay, we can do a couple of other things. Maybe just this one. Okay, we can isolate tools by, for instance, just graph databases, right? So here we have a list of graph databases. For each tool, we know actually what it's doing, right? It's not just that we have list of something, but because we have this ontology or taxonomy of tools, we can check for, I don't know, machine learning tools or and so on. So we can go a little bit deeper down. And just the last thing is, since we have also this real-time media, we can track AI and big data area in pretty much real time, who is writing about this, where at this particular moment. You see that this is roughly articles which are coming right now from the wire on the topic of AI. Okay, so this is part of DataBench toolbox. The point is to to observe this fairly complex ecosystem of AI and big data across like 6-7 dimensions in business real time. So by our knowledge, we are fairly unique in this. Usually similar approaches would have maybe 1 or 2 dimensional views. So here we have way more. Okay, so much from my side. Thanks, and I'll be available for questions later, right? Thanks.
Thank you very much, Marco. I think, Thomas, we go now to the last speaker. I think that our purpose is mainly to help people to understand the impact of big data technologies and also to promote their adoption. So looking at the adoption of the toolbox that we have created, we thought that one of the instruments that come to our mind when we think about adopting technologies is precisely the one of digital innovation hubs, no, Thomas?
Yeah, exactly. For that, we have today Daniel Seid from ITI that is going to present this this view from fostering this adoption and probably looking about also sustainability of this resource that we have from the point of view of the Digital Innovation Hub. So, Daniel, I will pass the slide for you. So the floor is yours.
Okay, thank you very much, Thomas, and thank you for inviting me to this session of DataBench. You can go to the next slide. I guess you all know about the digital innovation hubs and of course about data-driven or big data innovation hubs. For me and for us, BDBA made a very good definition of these data-driven innovation hubs in the strategic research and innovation agenda some time ago, where BDBA defined the I spaces as environments for data-driven innovation and experimentation, where companies, researchers, public administration can test, pilot, and also exploit data applications, data algorithms, and also manage data and learn how to manage data. And these I spaces combine for sure technical and non-technical elements. They are connected, very well connected to the regional level, but also to national and also international level. And they are also connected to the ecosystem of companies, large and small companies around them, in order to provide a very, very good ecosystem and a set of services to accelerate data-driven innovation. Next slide, please. So we can consider digital innovation hubs as a space where we have data, we have infrastructures, we have algorithms, and also we have people with knowledge. Please click to provide a local offer to the companies in the region. As a one-stop shop for supporting digitalization of SMEs and public administration, as I said before, providing neutral information and also infrastructures, access to data sets, access to infrastructures, but in a neutral information. This is important, and also important personalized assessment to companies, also in technology issues, but also in business models and business issues. And finally, these ISpaces, these digital innovation hubs can deploy, are prepared to deploy pilots, to deploy experiments, and test technologies in the infrastructures and with the data. So we are providing, next slide, please. So we are providing a local offer, but we are very well connected to Europe. And that's the objective of EU Hubs for Data project. You can see the map here at the right. DIHs are connected to other DIHs in Europe, and both together, all together, are defining a global catalog of data-driven services and also a global catalog of data sets. But once the catalog is defined at European level, the services and the attention to the companies is provided from the DIHs in a local offer, as I said before. So when we are addressing the needs of the companies, we have some problems, some barriers to cover. For example, we need use cases, successful use cases, demonstrators. We need metrics in order to compare one solution with another. We need to know where the networks are in Europe, where to find some partner for a consortium, for example. We need maturity models, which are running in other countries, in other regions. We need to know how to orchestrate all in the region, all the actors in the region, data sharing schemes, safe mode tests. And with these needs, we have defined, to cover these needs, we have defined a set of services. Please click. A set of services which are this list. I will not go one by one, but you can see technology selections, data maturity, digital assessment, research and development, proof of concept, and I think DataBench, as far as I know about the project and all what we have seen today, DataBench can be one important input for us, for the digital innovation hubs, and also for the network of digital innovation hubs, in order to find those metrics, those applications, the technology that are performed well in other applications, other use cases. And then please, I have selected those services where I think DataBench can provide or can be helpful. Technology selections, because we need to help companies to select a technology in order to start a project, a business. Data maturity and digital assessment, we need to know the reference, the baseline in order to compare. We can get DataBench information in order to establish strategic approaches for companies around data, for ecosystem building, for new business models definition, for observatory technology watch. DataBench has a very, very good observatory, as we said before, and also skills and training. So very, very, very quick. I think DIHs are the chain to connect all the data, the big data ecosystem, the big data application, big data projects, incubators, and so on, with the companies, and make a good impact from this project, delivering services to the local companies. So I think we have in DataBench a good partner to complete our services and make better services. Thank you.
Thank you very much, Danny. I think that we take your message. Basically, you see a value in the toolbox that we have developed. I think that we could spend several hours even discussing about the requirements, how SMEs are doing benchmarking, but unfortunately, we ran out of time. So we keep that as a future activity, because as we mentioned, the idea that we have been working now on this is that this is adopted by the companies and that we really foster the adoption of big data technologies. And maybe I would like to go directly to the concluding remarks before we close the session. Thank you again to you, Danny. So basically, from the people that are connected now, I don't see additional questions. If you represent a benchmarking community, please get in touch with us if you want your benchmark to be integrated in the toolbox. Also, if you want to talk to us about the way we can somehow talk to your community or give you some value, then if you are a potential user of big data technologies, you are representing a company, you are representing a project, and you have the kind of needs we've seen along the sessions today, also get in touch with us. As Thomas mentioned before, we are running a validation phase now. The project finishes at the end of the year. So for us, it's very important to count on you. We have even opened some validation threads in some platforms, and we are giving gifts for those people that will really contribute to improve somehow what we are doing in DataBench. So it's very important to count on your opinion as projects, as companies, big, small, as research organizations, provided you are somehow related to benchmarks. And then something that is also quite important, this session has been recorded. So you will find the recorded version both in the DataBench website, but you will also find it in the WOBA platform, I think. Presentations will also be available. And then we have run also different webinars in the past. So you may know that, maybe some of you have already attended them. All the webinars run so far are also available through the DataBench website, and a lot of resources are available to all of you in case some of the things that we have discussed in this session today are of interest to you. A lot of documents, a lot of material, and in any case, if for any reason you don't see something, please get in touch with us and we are more than glad to help you. With this, I would like to close the session today. I would like to say thank you to Richard as project coordinator, to the whole DataBench team that has been working on the presentations, to all our external speakers, and of course to all the attendees that have stayed here until so late for a long workshop. We appreciate that very much, and we are really thankful for all the contributions that you have made today. Richard, maybe you want to close formally the workshop today.
No, I don't think I could add anything more than what you already said, Nuria. Thank you very much for running this session so profitably. And anyone who wants more information or to get in touch with us, like Nuria said, can just go to our website where there's all the relative information. That's www.databench.eu. I'd like also to thank all of our speakers that have been just wonderful, and all of you attendees. So thank you very much and have a nice afternoon.
Thank you a lot, and
Thank
hope
you
to
very
see you all. Bye.
Bye-bye.
Thank you very much.
Bye-bye.
Bye-bye.
Bye.
Thank you.
Bye.
Bye.